Welcome to Secure and Scalable Cloud Infrastructure with Microsoft Azure. Cloud computing has revolutionized the way organizations approach IT, offering unmatched versatility and eliminating many challenges of traditional on-premises infrastructure. At the same time, implementing and maintaining a cloud setup requires a different approach to environment security and resource management. Fortunately, Microsoft has a solution to help you and your organization navigate this adjustment. That solution is Microsoft Azure, a cloud computing platform for building, deploying, securing, and managing cloud-based applications and services. In this course, you'll explore the intricacies of Azure. You'll begin with an exploration of Azure Compute and get hands-on experience with virtual machines, app service, and Azure Kubernetes Service or AKS. In addition to configuring these services, you'll learn troubleshooting techniques that ensure smooth operation in real-world scenarios. Following that, you will examine Azure networking. Imagine a company that needs to set up a secure and efficient network infrastructure in the cloud. This section will demonstrate how this company should configure its virtual network, implement load balancing, and incorporate identity and access management, otherwise known as IAM. Understanding these concepts will be crucial as you develop a robust network architecture for your Azure environment. Next, you will find out how to configure resources within the Azure environment for both efficiency and security. You will learn to do this with three essential tools, which are Azure CLI, Microsoft PowerShell, and Microsoft Sentinel. Mastery of these tools is essential for effective resource management and safety. Through practical exercises, you'll gain the expertise to secure your Azure environment effectively. Each section of the course combines theory with hands-on activities to reinforce your learning. From deploying virtual machines and configuring app services to managing Kubernetes clusters and securing your network, you'll gain practical experience that mirrors real-world applications. Additionally, quizzes and interactive lessons ensure that you understand the material thoroughly and can apply it confidently. Finally, you will conclude this course with a final project and graded assessment. The project will challenge you to design, deploy, and manage a secure and scalable Azure environment. By completing it, you'll understand how to leverage Azure's compute, networking, and security services to meet your organization's needs. Beyond gaining real-world skills, there is an additional benefit to gain by completing this course. It will help prepare you for the AZ-900 Microsoft Azure Fundamental Certification exam. Successful completion of this exam provides proof of your Azure expertise and job readiness and plays a valuable role in advancing your IT career. So now that you know what to expect, let's get started and take your Azure mastery to new heights. Imagine you're working on a new application for your employer, but your current hardware setup is holding you back. As your project grows, you need more power, flexibility, and the ability to scale effortlessly. This is where Azure Virtual Machines, or VMs, come in. These virtual computers, hosted in Azure's extensive data centers, provide on-demand, scalable computing power without the hassle of maintaining physical hardware. Azure VMs offer unparalleled control over your computing environment, perfect for scenarios requiring specific configurations or high customization. In this video, you'll explore what makes Azure VMs a versatile and cost-effective solution. You'll discover their use cases, setup considerations, and other available features. Let's start by exploring why more and more organizations are opting for Azure VMs. As mentioned, VMs offer on-demand, scalable computing power at your fingertips. They are one of the many ways Azure lets you leverage cloud resources. Think of them as virtual computers residing within the vast Azure data centers. The beauty lies in the flexibility of virtualization, offering all the benefits without the burden of purchasing and maintaining physical hardware. Furthermore, they offer exceptional control over your computing environment. This makes them perfect for situations where you require specific configurations or a high degree of control over your infrastructure. Azure VMs can be used in numerous ways, limited only by your imagination. Some common applications include development and testing. Azure VMs help you set up a virtual machine quickly and easily with the exact configuration your application requires for coding and testing. Next, Azure VMs allow for applications in the cloud. Maybe your resource demands fluctuate. With Azure VMs, you can effortlessly scale resources up or down based on real-time needs. Pay only for what you use, making it a cost-effective solution. And extended data centers. Azure VMs seamlessly integrate with your organization's existing network, acting as an extension of your on-premises data center. There are several considerations you should make prior to creating your VM, including resource name. Ensure you choose clear and descriptive names for your VMs and related resources for easy identification. You should also choose the geographical location wisely, as this will determine where your virtual hard disks reside. Next, Azure offers a variety of VM sizes catering to different processing power, memory, and storage needs. Determine the ideal size based on your workload, and remember that there might be limitations on the number of VMs you can create. You should also select the operating system that best suits your needs, either Windows or Linux. Customize your VM configuration with additional settings like storage options and network configurations. Another important consideration when creating a VM is to remember that you're essentially building an ecosystem. This can impact billing depending on the additional supporting resources you need, including virtual networks. These act as the communication highway for your VM, enabling it to connect with other resources. A network interface card, or NIC. Think of this as your VM's network adapter, allowing it to connect to the virtual network. Also, Network Security Group, or NSG, acts as a security guard, managing incoming and outgoing network traffic for your VM. And OS and data disks. Imagine separate disks for your operating system and your actual data. This keeps things organized and efficient. Azure VMs include the following features. The beauty of Azure VMs is their global reach. You can create them in multiple geographical regions. Remember, the location you choose determines where your virtual hard disks are stored. Azure also offers features like availability zones and virtual machine scale sets to ensure high availability and scalability for your VMs, making sure your applications are always up and running. The size of your VM significantly impacts factors like processing power, memory, storage capacity, and network bandwidth. However, Azure charges you based on the VM size and operating system you choose, with storage costs being separate. To optimize costs, carefully consider your workload requirements and choose the most suitable VM size. Azure Managed Disks can also automatically handle Azure Storage account creation and scalability in the background. All you need to do is specify the disk size and performance tier, and Azure takes care of the rest. When it comes to operating systems, Azure offers a wide selection. You can choose from popular Linux distributions like Ubuntu and CentOS, as well as various Windows Server versions. Finding the perfect fit is easy. Simply browse available distributions through the Azure portal, command line interface or CLI, PowerShell, or even REST APIs. Rest assured, Microsoft optimizes these pre-configured images to run smoothly on Azure. Azure also supports Cloud Init, a popular cloud initialization tool. This simplifies deployments and configurations for your VMs and VM scale sets. Cloud Init allows you to pre-configure settings like users, SSH keys, and packages during the VM creation process, saving you valuable time and effort. In conclusion, Azure VMs empower you with a flexible, scalable, and cost-effective solution for a wide range of computing needs. They offer exceptional control, seamless cloud integration, and a variety of features to cater to diverse scenarios. Whether you're a developer building a test environment, a company scaling your application, or an organization extending your data center, Azure VMs are a powerful asset to have in your cloud computing toolkit. In this video, you'll learn about the various ways you can deploy VMs in Azure, discuss OS integration, and tackle some common issues you might face along the way. By the end, you will have a solid understanding of what deployment means and how to deploy your Azure VMs effectively. Azure offers several deployment options to suit different needs and preferences. In this video, you will explore how to deploy VMs through the Azure portal, Azure CLI, Azure PowerShell, and ARM templates. However, it is important to note that you can also deploy VMs using Azure DevOps and third-party tools like Terraform. Each method has its own advantages, and the best choice depends on your specific requirements and workflow. Let's start with the Azure portal. You'll find the Azure portal to be the most user-friendly option, providing you with a graphical interface to configure and deploy VMs without writing any code. This makes it an excellent choice for those who prefer a visual approach to deployment. Here's how you do it. Firstly, navigate to the Azure portal at portal.azure.com and log in with your Azure account credentials. Next, in the Azure portal, enter Virtual Machines in the search bar and select Virtual Machines under the Services category. Now, on the Virtual Machines page, click on Create and then select Azure Virtual Machine. This will open the Create a Virtual Machine page. Then, under the Instance Details section, enter My VM for the virtual machine name and choose Windows Server 2022 Data Center and Azure Edition x64 Gen 2 for the image. You can leave the other defaults as they are. Now it's time to configure your administrator account. In this section, provide a username such as Azure User, then set a password for the administrator account. Now, under the Inbound Port Rules section, choose Allow Selected Ports and select RDP 3389 and HTTP 80 from the drop-down list to allow remote desktop and web traffic. Once you're happy with everything you have selected, scroll to the bottom of the page and click the Review plus Create button. Once the validation runs, click the Create button at the bottom of the page to start the deployment. Once the deployment is complete, click on Go to Resource to access your newly created VM. By following these steps, you've successfully deployed a VM using the Azure portal. This method is perfect for users who prefer a graphical interface and need to quickly set up and manage VMs without diving into scripting or automation. Next, let's look at deploying VMs using Azure CLI. Azure CLI is a more preferable method, perfect for those who prefer command line tools and need to automate deployments. This command sets a basic name and username. The zvm command creates a VM in the specified resource group with a Windows Server 2022 Azure Edition core image. Azure CLI is a powerful tool for scripting and automation. It's ideal for users who prefer using command line tools and need to automate repetitive tasks efficiently. Another deployment method available is Azure PowerShell, another command line tool tailored for those comfortable with PowerShell scripting. With PowerShell, you can deploy a VM by entering the following command. In this script, new-azvm is the command to create a new virtual machine, while resource group name specifies the resource group in which the VM will be deployed. You can then name the VM and specify the Azure location. Image defines the VM image to be used, in this case, Windows Server 2022 Data Center Azure Edition, while the virtual network name, subnet name, and security group name configure the network settings. Azure PowerShell offers robust scripting capabilities, making it particularly useful for managing Azure resources in a Windows-centric environment. If you're familiar with PowerShell scripting, you'll find it to be an excellent choice for automating complex deployment tasks. Lastly, there are ARM templates for those who prefer infrastructure, such as Code or IAC, which offer a declarative method to deploy VMs. By specifying your VM's configuration in a JSON file, Azure Resource Manager handles the deployment process. ARM templates are perfect for repeatable and consistent deployments, especially in complex environments. By defining your infrastructure as code, you ensure that deployments are predictable and maintainable over time. This approach is ideal for those who need to manage complex environments and prefer a programmatic method for infrastructure management. In this video, you focused on the main methods for deploying VMs in Azure. However, it's important to note that Azure DevOps and Terraform are also powerful tools for managing deployments, especially in complex or multi-cloud environments. These tools enable you to achieve advanced automation and seamless integration into CI pipelines, offering enhanced control and efficiency. As you've witnessed, Azure offers a range of deployment methods for virtual machines, each suited to different preferences and needs. Whether you prefer the user-friendly interface of the Azure portal, the automation capabilities of Azure CLI and Azure PowerShell, or the declarative approach of ARM templates for repeatable deployments, Azure has you covered. By understanding these options, you can choose the best approach for your specific scenario, ensuring efficient and effective VM deployments in Azure. Imagine you're managing your organization's website and have opted for a low-cost virtual machine with standard storage to balance performance and cost. One day, customers begin reporting slow page loads and connectivity issues. How would you address this problem? That's where Azure can help. Azure Virtual Machines, or VMs, provide a wide range of configuration options to meet your specific needs. In this video, you will explore these advanced configuration options that Azure offers, focusing on VM sizes, storage options, and common operating system challenges. You'll also discover how to optimize your setup for better performance, reliability, and cost efficiency. Let's start with VM sizes, which Azure offers in a range tailored for different workloads. First up are general-purpose VMs, which are balanced in terms of CPU to memory ratio. They are ideal for testing, development, and small to medium databases. Examples include the B series, DV3, and DV4 series. Next are compute-optimized VMs, which are designed for CPU-intensive applications like batch processing and web servers. Examples are the F-series VMs. You also have memory-optimized VMs. These have a high memory to CPU ratio and are suitable for relational databases, in-memory analytics, and other memory-intensive applications. The EV3 and M series are prime examples. Next are storage-optimized VMs. Imagine you need high disk throughput and I/O, such as for big data, SQL, and NoSQL databases. The LSV2 series VMs are designed for these needs. Additionally, there are GPU VMs, which are ideal for heavy graphics rendering and video editing, as well as model training for AI and deep learning. Examples of these include NV and NC series. Last up are high-performance compute or HPC VMs, which are used for the most demanding workloads like molecular modeling and scientific simulations. The H series is an example of HPC VMs. Now let's explore another vital aspect of VM configuration: storage. Azure provides several storage options to match your performance and cost requirements, including Azure Managed Disks, which are the most common storage options for VMs. They come in three types: standard HDD, which is a cost-effective storage type that is suitable for backup and non-critical data. You also have standard SSD, which offers a balance between performance and cost and is ideal for web servers and likely used enterprise applications. And Premium SSD, which is a high-performance storage system for mission-critical applications. It's ideal for production workloads and databases. Next is Ultra Disks. These provide the highest performance with low latency and are designed for data-intensive workloads such as SAP HANA, top-tier databases, and transaction-heavy workloads. You also have temporary disks. Each VM has a temporary disk known as the D drive on Windows VMs. These temporary disks provide short-term storage for applications and processes but should not be used for storing persistent data. And lastly, you have Azure Blob Storage. Blob storage can be a cost-effective way to store data with options for hot, cool, and archive storage tiers. While VMs provide a wealth of features and configuration options, you may still face several challenges when working with your Azure VM, including boot errors. Having incorrect configurations or missing files could cause your VM to fail during boot. Patch failures that have not been updated or installed correctly could lead to security vulnerabilities. You may also encounter network configuration issues if incorrect settings are applied, leading to connectivity problems. If you have insufficient disk space, it could affect performance and prevent updates. Unpatched systems and misconfigured firewalls can expose your VM to security vulnerabilities. Performance bottlenecks may lead to inadequate resource allocation, which can slow the performance of your VMs. And lastly, backup failures, incomplete or failed backups could jeopardize data recovery. Remember, by addressing these issues promptly, you can ensure that your VMs remain secure, reliable, and efficient from the outset. In conclusion, managing VMs involves balancing performance and cost, a task facilitated by Azure VM. Remember, when customers report slow page loads and connectivity issues, Azure offers robust solutions. This video explored these configuration solutions, covering VM sizes tailored for diverse workloads, storage options ranging from managed disks to Azure Blob Storage, and common OS challenges like boot errors and security vulnerabilities. Addressing these issues will ensure that your VMs operate correctly and maintain optimal performance for your website's visitors. Imagine a scenario where you're managing a platform for your organization during a major online sale. However, during the sale, the website experiences a surge in traffic, leading to performance bottlenecks, all while cyber threats are an increasing risk. How could you ensure that your Azure Virtual Machines or VMs can handle the increased load and stay secure? This video will explore how to achieve this balance, guiding you through the best practices for optimizing both the performance and security of your VMs. Whether you're overseeing a small number of VMs or managing a large-scale deployment, maintaining optimal performance and robust security is crucial. To begin, let's explore some essential practices for optimizing performance. First is resource allocation, which ensures each VM has the right amount of CPU, memory, and storage. Over-allocating resources can lead to waste, while under-allocating can cause performance bottlenecks. To find the sweet spot, monitor your VM performance regularly and adjust resources based on actual usage patterns. Keep your VM up to date with regular updates and patches. This can improve performance and fix bugs. Use automated patch management solutions to ensure no critical updates are missed. Next, use fast storage options like SSDs for better I/O performance. Consider using storage tiering to balance cost and performance, allocating high-performance storage to critical applications and lower-cost options to less demanding tasks. You should also optimize network configuration settings to reduce latency and improve throughput. Use dedicated network interfaces for high-demand applications and configure quality of service or QoS settings to prioritize critical traffic. Next, robust monitoring tools should be implemented to track performance metrics like CPU usage, memory consumption, and disk I/O. This helps identify and address issues proactively before they impact end users. You should also distribute workloads evenly across multiple VMs to avoid overloading a single machine. To manage traffic efficiently, implement both internal and external load balancers. Lastly, auto-scaling can be used to adjust resources based on demand. This ensures optimal performance during peak times and cost savings during low usage periods. Set thresholds and policies that trigger scaling actions automatically. Next, let's focus on security. Protecting your VMs from threats is just as important as optimizing their performance. First, always apply the latest security patches to your VMs. Use centralized management tools to track and deploy updates consistently. Next, implement strict access controls. Use multi-factor authentication and role-based access control, or RBAC, to ensure only authorized users can access VMs. Regularly review and update permissions. Use firewalls and network segmentation to isolate VMs from potential threats. Implement VPNs for secure remote access and consider using advanced security solutions like intrusion detection and prevention systems, or IDPS. To protect sensitive information, you should also encrypt data at rest and in transit. Use strong encryption standards and manage encryption keys securely. Schedule regular backups to recover data in case of an attack or failure. Store backups securely, ideally in a different location, and regularly test the backup and recovery process. Use security monitoring tools to detect and respond to threats in real time. Implement security information and event management, or SIEM systems, to collect and analyze security-related data. And lastly, ensure your VMs comply with industry standards and regulations. Regular audits can help maintain compliance and identify areas for improvement. Document and review compliance efforts continuously. Balancing performance and security is key. Sometimes improving security measures might slightly impact performance and vice versa. Here's how to find the right balance. First and foremost, Performing routine audits to evaluate both performance and security can aid in pinpointing areas for enhancement. Next, tools that offer both performance monitoring and security features should be used. This integration simplifies management and improves efficiency. Lastly, train your team on best practices for both performance optimization and security. An informed team is your best defense. Optimizing VM performance and security is an ongoing process that requires vigilance and adaptation to new challenges. By following these best practices, you can ensure your VMs are both efficient and secure, ready to handle any situation your organization faces. Imagine you're developing a web application for your organization with high demands for speed, reliability, and scalability. To meet these demands, you choose Azure App Service. Azure App Service is a fully managed platform that simplifies building, deploying, and scaling web apps. It supports a wide variety of programming languages and frameworks, offering developers a versatile and powerful toolset. With Azure App Service, you can focus on writing code and creating impactful features without worrying about underlying hardware, networking, or infrastructure, as Azure takes care of all that for you. In this video, you'll learn about Azure App Service's features and capabilities and discover why it's the preferred choice for developers seeking efficiency and performance. Let's begin by exploring the diverse language and framework support Azure App Service offers. It includes multiple programming languages such as .NET, Java, Node.js, PHP, Python, and Ruby, allowing you to develop your application in your preferred language. Whether you're creating a simple website, a complex API, or a full-scale enterprise application, Azure App Service caters to your needs. This flexibility lets you leverage your existing skills and code bases, making development faster and more efficient. Next, let's discuss how Azure App Service seamlessly integrates with popular Integrated Development Environment or IDEs like Visual Studio and Visual Studio Code. These integrations offer a streamlined development experience, providing features like code completion, debugging, and integrated source control. This tight integration means you can deploy your applications directly from your IDE, making your workflow smoother and more productive. The ability to work within the familiar environment of your preferred IDE enhances productivity and allows for a more efficient development process. Additionally, with Azure App Service, you can enable continuous deployment from source control systems such as GitHub, Bitbucket, and Azure DevOps, ensuring your application stays current with the latest changes and features. Every time you push a change to your repository, Azure App Service can automatically build and deploy your application, reducing the time between development and production. Continuous deployment also means fewer manual steps, which reduces the risk of human error and makes your deployment process more reliable and consistent. Another brilliant feature is built-in auto-scaling, which can automatically adjust the number of running instances for your application based on demand. During peak traffic times, Azure App Service can scale out to handle the increased load and then scale back down when the demand decreases. This dynamic scaling helps optimize resource usage and cost, ensuring your application performs well without over-provisioning resources. This feature is beneficial for applications that encounter fluctuating levels of traffic, ensuring high performance without resource wastage during periods of low activity. Another awesome thing about Azure App Service is its high availability feature. It's designed to keep your app running smoothly no matter what, with things like load balancing, automated backups, and quick disaster recovery. Basically, it ensures your application is always up and ready for users to access. This high availability is critical for applications that need to be reliable and provide a consistent user experience. You can trust that your application will remain accessible to users even during maintenance or unexpected downtime. Plus, with Azure App Service, you get global reach. This means you can deploy your app in data centers all over the world. By doing this, your app runs faster for users because it's served from locations closer to them. It's all about giving your users a great experience no matter where they are. Whether your users are in North America, Europe, Asia, or anywhere else, they can access your application quickly and reliably. This geographic flexibility helps you deliver a seamless user experience, no matter where your users are located. When it comes to Azure App Service, security is a top priority. It's got all the essentials covered, like SSL certificates, custom domain support, and seamless integration with Entra ID to keep your app safe and sound. These features ensure a secure environment for your applications, protecting sensitive data and meeting compliance requirements. You can easily configure SSL to encrypt data between your application and its users and use Entra ID to manage user access and authentication, making it easier to secure your application and protect your users' data. And lastly, let's discuss monitoring and diagnostics. Azure App Service offers powerful tools like Azure Monitor and Application Insights. These tools give you a clear view of your app's performance, making it easier to spot and fix any issues quickly. You can track metrics like response times, error rates, and user interactions, allowing you to optimize your application for better performance and reliability. These insights enable you to proactively address potential issues before they impact your users, ensuring a smooth and high-performing application. In conclusion, Azure App Service stands out as the ultimate choice for developers seeking speed, reliability, and scalability in web application development. Its robust features simplify the process of building, deploying, and scaling web applications. Whether you're building a simple website or a complex enterprise application, Azure App Service provides the tools and support needed to meet your development goals efficiently and effectively. Imagine you're a developer tasked with launching a new web app for your organization. Ensuring the app functions flawlessly and remains secure is crucial. This is where Azure App Service steps in. Azure App Service equips you with all the tools necessary for seamless web application deployment and effective scaling. Deployment involves transitioning your application from development to a live environment where users can interact with it. Scaling, on the other hand, addresses increased workloads by adjusting resources. This scaling can either be vertical, which enhances the capacity of existing resources, or horizontal, where additional instances of resources are added. In this video, you learn about the capabilities of Azure App Service, discover various deployment methods, and learn how to scale your application to accommodate increasing user demands efficiently. Let's start by exploring the various deployment strategies. These include manual deployment, which allows you to move your web app directly from your local environment to Azure. Tools like Visual Studio and Azure CLI make this straightforward. To deploy using this method, you first open it in Visual Studio, then click on Publish. Now connect to your Azure account and select your app service instance. Within a few clicks, your app will go live. Next is continuous deployment. In this case, instead of deploying manually every time you make changes, continuous deployment automates this process. It's like having a robot that updates your app whenever you push new code. To do this, firstly, link your GitHub or Azure DevOps repository to Azure App Service. Then, configure the pipeline so that every time you commit changes, the robot or pipeline automatically builds and deploys your app. You can also choose container deployment. This involves using Docker to package your app into a container. This container includes everything your app needs to run, ensuring it works consistently across different environments. First, simply write a Docker file for your app. After that, build your Docker image locally. From the local terminal where you built the sample image, use the Docker login command to sign in to the container registry. When the sign-in is successful, tag your local Docker image to the registry. Use the Docker push command to push the image to the registry. Uploading the image the first time might take a few minutes because it includes the base image. Subsequent uploads are typically faster. You then simply tell the Azure App Service to use this container for deployment. Finally, let's talk about staging environments. Before rolling out updates to all your users, staging environments allow you to test these changes in a secure, isolated space. Think of it as a dress rehearsal before the big performance, ensuring everything runs smoothly before the main event. To do this, you first, in Azure, create a staging slot, then deploy your app updates to the slot. Next, test it thoroughly, and then swap the staging slot with the production slot to go live seamlessly. Now let's discuss the various scaling strategies you have for your applications. First is vertical scaling, which means boosting the power of your existing server. Think of it as upgrading your car's engine to make it go faster. To do this, navigate to your app service in the Azure portal, click on Scale Up, and choose a higher pricing tier that offers more resources like CPU and memory. Next is horizontal scaling, which adds more servers to handle increased load. It's like adding more lanes to a highway to reduce traffic congestion. To do this, set up your app service plan to scale out. Define rules that automatically add or remove server instances based on usage metrics like CPU load and request count. Last is auto-scaling, which automatically adjusts the number of running instances based on traffic. It's like your highway expanding and contracting based on the number of cars. To do this, configure auto-scaling rules in Azure. Set thresholds for scaling actions, such as adding instances when CPU usage exceeds a certain percentage and removing instances when it drops. Another highlight of Azure App Service is how it integrates with other Azure services. These include Azure Monitor and Application Insights, which help you to monitor your app's health and performance. They are like fitness trackers for your application. You can enable Azure Monitor and Application Insights in your app service and use the dashboards to monitor metrics like response times and error rates. Next is Azure DevOps, which provides a full suite of tools for managing your app's lifecycle from planning to deployment. To automate the deployment process, we can create a project in Azure DevOps, set up repositories, and configure build and release pipelines. You also have Azure Virtual Network and hybrid connections, which allow your app to connect securely to other resources, whether in the cloud or on-premises. In the Azure portal, you can set up virtual networks and hybrid connections to securely connect your app service to the required resources. Go to Networking in the App Service portal. Under Outbound Traffic Configuration, select Virtual Network Integration. Select Add Virtual Network Integration. Then there's Azure Functions, which lets you run small pieces of code without managing servers. This is perfect for on-demand tasks like having your own personal butler. To create a function in the Azure portal, just write your code and set up triggers to run it based on specific events. Last up is Azure Front Door and Application Gateway. These services are excellent for global load balancing and enhanced security. They act like gatekeepers, ensuring your app traffic flows smoothly and securely. You can configure Azure Front Door for optimized traffic distribution and Application Gateway for robust firewall protection. Just be sure to establish rules to manage both incoming and outgoing traffic effectively. In summary, Azure App Service offers a powerful and adaptable platform for deploying and scaling web applications. By using various deployment options, scaling strategies, and integrations with other Azure services, you can ensure your application remains highly available, performant, and secure. Imagine being able to create applications with just a few clicks. That's the power of the Azure portal. With its intuitive and user-friendly interface, the Azure portal makes creating a web app easier than ever. In this video, you'll learn how to create a web app step by step using the Azure portal. To get started, sign in at portal.azure.com. Once you have done so, you'll see the Azure portal homepage. Now, on the left-hand menu, click on Create a Resource. This is where you can begin creating any Azure resource. Next, within the Create a Resource pane, you have several categories and a search bar. Since we are creating a web app, you can either search for Web App in the search bar or click on Web under the Azure Marketplace section. Next, click on Create Web App under Web App from the list of options. This opens the Create Web App pane, where you'll configure your new web app. The subscription is where you can choose the Azure subscription you want to use. You can also choose an existing resource group or create a new one by clicking Create New. You then enter a unique name for your web app. This name will be part of your app's URL, so make sure it's unique. You also select Code in the Publish category to deploy code directly. In Runtime Stack, choose the runtime stack your application will use, such as .NET, Java, Node.js, PHP, or Python. In this scenario, .NET 8 was chosen. Now, select the operating system, either Windows or Linux. Then choose the Azure region where your web app will be hosted. For better performance, pick a region closest to your users. Now you can select the pricing plan that suits your needs. For this scenario, standard S1 was chosen, which provides a good balance of cost and capabilities. The rest can be left in default, with no changes done. After filling out the form, click Review plus Create at the bottom of the page. This will take you to a summary page where you can review all your settings. If everything looks correct, click Create to begin the deployment process. Azure will now create your web app, and you can track the progress on the screen. You should be aware that this process may take a few minutes. Once the deployment is complete, you will get a notification where you can click Go to Resource to navigate to your newly created web app. You are now in the App Service Overview pane. This is your control center for managing your web app. Here, you can see the URL, monitor performance, configure settings, and more. To view your web app, click on the Browse button or URL provided in the Overview pane. This will open your app in a new browser tab. The default page you encounter confirms that your web app is up and running. This placeholder page, provided by Azure, indicates that your web app is ready for deployment. Congratulations! You have successfully created a web app using the Azure portal. With your app now up and running, you can proceed to deploy your code and begin building amazing applications. The intuitive and user-friendly interface of the Azure portal streamlines the entire process, making it easier than ever to create, manage, and scale your web apps. Now, leverage this powerful platform to develop and deploy robust, high-performing applications for your users. Happy coding! Imagine you're developing a web application for your organization. You have a front end that handles user interactions, a back end for business logic, and a database for storing user data and orders. Traditionally, each of these components is tightly integrated with the operating system, leading to difficulties in deployment, scaling, and ensuring consistency across different environments. This is where containers come into play. Containers encapsulate the application into a single portable package, simplifying deployment across various environments. This concept is central to modern application deployment, but it can be daunting if you're new to the field. In this video, you'll gain an understanding of containers, discovering what they are and how they work. Let's start by breaking down what a container is and why it's essential. A container is a lightweight, standalone, executable package that includes everything needed to run a piece of software, including the code, runtime, system tools, libraries, and settings. This encapsulation isolates the application from the host operating system, ensuring that it runs consistently across different environments. In traditional application deployment, each component is tightly integrated with the OS, leading to challenges in deployment and scaling. With containers, each component runs independently, sharing the OS kernel but isolated from each other. This isolation enhances security, stability, and efficiency. Because they are lightweight and efficient, multiple containers can run on a single OS instance. By sharing the OS kernel while maintaining isolation between applications, they can also maximize resource utilization. However, managing containers at scale can be challenging, which is where container orchestration platforms like Kubernetes come in. By leveraging containers, you can streamline the deployment process, improve application consistency across environments, and enhance scalability and resource efficiency. Services like Kubernetes, an open-source system for automating the deployment, scaling, and management of containerized applications, group containers into logical units for easy management and discovery. Kubernetes handles the scheduling of containers onto a cluster of machines and manages the workload to ensure that the application runs as intended. It also provides self-healing capabilities like restarting failed containers, rescheduling them when nodes die, and killing containers that don't respond to user-defined health checks. One such Kubernetes service is Azure Kubernetes Service, or AKS. AKS is Microsoft's managed Kubernetes service designed to simplify the deployment of Kubernetes clusters in Azure. By offloading operational tasks such as health monitoring, maintenance, and scaling to Azure, AKS allows you to focus on building and running your applications without worrying about the underlying infrastructure. AKS provides the benefits of Kubernetes without the complexity of managing the infrastructure. It also integrates seamlessly with other Azure services, providing enhanced security, monitoring, and scalability. This makes it easier for you to manage your containerized applications and focus on developing your solutions. AKS offers several key benefits, including simplified deployment. AKS automates the provisioning, upgrading, and scaling of resources so you can focus on your applications instead of the infrastructure. It also provides integrated developer tools by working with Azure DevOps, Visual Studio Code, and GitHub to provide a comprehensive development environment. It also has enterprise-grade security through its built-in security features such as Entra ID integration, managed identities, and network policies to safeguard your applications. And with Azure Monitor and Azure Log Analytics, AKS offers essential monitoring and diagnostics of your containerized applications, helping you troubleshoot and optimize performance. These benefits help streamline your workflow, enhance security, and improve the management of your applications, allowing you to focus on what you do best, developing innovative solutions. In addition to these benefits, AKS is engineered to support a well-architected framework. This ensures operational excellence. AKS helps you to manage and automate operational processes, reducing the risk of errors and increasing efficiency. It also ensures reliability with built-in self-healing capabilities and seamless integration with Azure's robust infrastructure. AKS ensures your applications are highly available and resilient. AKS also optimizes resource usage and provides tools to monitor and enhance application performance. And cost management. By leveraging AKS's automated scaling and resource management features to optimize your spending and ensure cost-effective operations. Additionally, Azure offers a variety of container services to meet diverse needs, including the following. Use Azure Red Hat OpenShift to simplify deploying and managing OpenShift clusters on Azure. Use Azure Container Apps for a serverless platform that provides event-driven autoscaling and integrated monitoring. Azure Functions, a serverless compute service, can run event-driven code without provisioning infrastructure. Azure Container Instances offer a fast and straightforward way to run containers with increased security. With Azure Service Fabric, you can deploy and manage microservices and containers, providing comprehensive application lifecycle management. Use Azure Container Registry, which works with Docker and Kubernetes, to manage container storage. Azure Container Registry works by creating and storing containers in Azure Container Registry, just like placing boxes in a secure warehouse. It then keeps track of all your containers, ensuring they are safe and organized. And simply pulls out a container when needed, just like retrieving a box from storage. With these services, Azure ensures that you have the right tools for your container needs, enhancing efficiency, security, and cost management. In conclusion, containerization enables you to package applications with all their dependencies, ensuring consistency across different environments. Kubernetes offers robust tools for orchestrating these containers, while AKS streamlines the process, allowing you to easily scale and manage your applications with minimal operational overhead. By now, you should be familiar with Azure Kubernetes Service, Microsoft's managed Kubernetes offering. Azure Kubernetes Service, or AKS, is designed to simplify the deployment and management of Kubernetes clusters in Azure. With AKS, you can quickly deploy and manage clusters with ease. An AKS cluster consists of virtual machines or VMs running containerized applications, all managed by Kubernetes. By harnessing Kubernetes' capabilities and offloading operational overhead to Azure, AKS makes deploying, managing, and maintaining your containerized applications more straightforward. In this video, you will learn about the various benefits of using AKS and then discover how to create an AKS cluster using the Azure portal. Let's start by exploring the benefits of using AKS for cluster creation. AKS handles many of the complexities of Kubernetes management, such as health monitoring, maintenance, and scaling, allowing you to focus more on developing your applications rather than managing the infrastructure. AKS also integrates seamlessly with Azure services, offering enhanced security, monitoring, and scalability. Additionally, by automating tasks like scaling and resource management, AKS helps optimize costs and ensures efficient resource use. Lastly, AKS provides built-in security features, including network policies and integration with Azure Active Directory for authentication and authorization. Now let's discover how to create an AKS cluster using the Azure portal. First, sign in to the Azure portal and on the home page, select Create a Resource. In the Categories section, choose Containers and then Azure Kubernetes Service, then select Create. Now, within the Basics tab, select your Azure subscription and create a new resource group such as My Resource Group. To avoid impacting your production or development workloads, it's best to create a separate resource group for testing or evaluation purposes. Now, under Cluster Details, set the cluster preset configuration to Dev Test. Enter a Kubernetes cluster name like My AKS Cluster. Next, select a region for your AKS cluster. Now, set the Availability Zones setting to None and set the AKS pricing tier to Free. Leave the default value for the Kubernetes version and ensure the automatic upgrade setting is enabled with Patch. Lastly, set the authentication and authorization to local accounts with Kubernetes RBAC. Next, move to the Node Pools tab to add a new node pool. Start by clicking Add Node Pool. Now enter a node pool name such as NP Linux. Next, set mode to User and choose Ubuntu Linux for the OS SKU. You can set availability zones to none and just leave the Enable Azure Spot Instances checkbox unchecked. For node size, click Choose a Size. Just select D2S_V3 and then select. You can leave the Scale method set to autoscale with the default minimum and maximum node counts, and leave the labels and tains as blank. Leave all of the settings on their default values. Once done, select Review plus Create to run validation. After validation is complete, click Create to create the AKS cluster. This process takes a few minutes. Once your AKS cluster is created, navigate to your resource by selecting Go to Resource or browsing to the AKS cluster resource group and selecting the resource, for example, My Resource Group and My AKS Cluster. Great! You have deployed an AKS cluster. Let's connect to it using kubectl, the Kubernetes command line client. With kubectl, you can manage your Kubernetes cluster. This may be already installed if you're using Azure Cloud Shell. If not, you'll need to install it on your local machine. To begin, in your Azure portal, click the Cloud Shell icon at the top, select PowerShell and click Apply. If opening for the first time, select No Storage Account Required, select your subscription and click Apply. This opens a shell environment directly in your browser with all the tools you need. To configure kubectl, connect to your AKS cluster. Use the import-AZ-AKS credential command let. Import-AZ-AKS credential -resource group name My Resource Group -name My AKS cluster. This command let downloads the necessary credentials and sets up kubectl for you. Now import your cluster using the name you assigned to your AKS cluster. Now you need to verify the connection by running kubectl get nodes. This command lists the nodes in your cluster. You should see an output similar to this. Great job! You've now explored the various benefits of using AKS and successfully deployed an AKS cluster. Additionally, you've learned how to connect to your cluster using kubectl. By leveraging AKS, you've simplified the process of managing Kubernetes clusters, allowing you to focus more on developing and maintaining your containerized applications. With its integrated tools, cost efficiency, and robust security features, AKS provides a powerful and efficient platform for your containerized workloads. Continue experimenting with AKS to harness its capabilities and enhance your application deployment processes fully. Imagine you've deployed your Azure Kubernetes Service or AKS cluster and there's a sudden surge in online traffic. How will your AKS cluster handle this additional traffic? In this scenario, scaling your AKS cluster quickly will allow it to handle the increased load. This is where AKS management comes in. In this video, you'll discover how to manage your AKS cluster to ensure it runs smoothly even during high traffic periods. By mastering these steps, your AKS cluster will efficiently handle any traffic surge. Begin by navigating to the AKS dashboard in the Azure portal. This is your control center for managing everything related to your AKS cluster. Here you can monitor performance, scale your cluster, update configurations, and much more. One of the first things you'll want to do is ensure your cluster is running smoothly. Let's start by checking the health of your nodes. Open Azure Cloud Shell and run the command kubectl get nodes to get a list of your cluster nodes and their status. This command will return a list of nodes along with their status. If any of your nodes are not in a ready state, you'll need to investigate further. Now let's use the kubectl describe node command to get detailed information about the node and troubleshoot any issues. Next, you should explore scaling your cluster. This allows you to adjust the number of nodes in your cluster based on demand, ensuring that your applications have the resources they need without over-provisioning. To set up auto-scaling, go to the Node Pools tab in your AKS cluster settings. Select your node pool and enable auto-scaling. You can set the minimum and maximum number of nodes here. Auto-scaling helps you manage costs effectively by only using the resources you need. It's a great way to ensure your cluster can handle varying workloads without manual intervention. Another important aspect of managing your AKS cluster is keeping it updated. Regular updates ensure that your cluster has the latest features, security patches, and performance improvements. To update your AKS cluster, navigate to the Settings section and select Cluster Configuration. Here you can choose the Kubernetes version you want to upgrade to. Always review the release notes and test updates in a staging environment before applying them to production. Another crucial aspect of managing any Kubernetes cluster is monitoring. AKS integrates seamlessly with Azure Monitor, providing you with detailed insights into your cluster's performance and health. In Azure Monitor, you can view metrics like CPU usage, memory consumption, and network activity. Setting up alerts can help you stay informed about any issues that need your attention. You can also set up an alert in Azure Monitor by selecting Alerts and creating a new alert rule. Just make sure to define the conditions that trigger the alert and specify the action groups that should be notified. You will explore this further later. Another critical aspect is managing access and identity. AKS supports Entra ID integration, allowing you to manage user access to your cluster using Entra ID identities. Lastly, deploying, updating, and managing applications is straightforward with kubectl and Helm. To deploy an application, you can use a YAML manifest file with kubectl as shown in this example. Managing an AKS cluster involves monitoring, scaling, updating, and securing your resources. By following these steps, you can ensure your cluster runs efficiently and securely. Keep practicing and you'll master AKS management in no time. Imagine your organization is in the process of deploying a new application, but you're facing challenges with scaling, resource management, and maintaining uptime. How can you overcome these challenges and achieve the desired performance? This video will show you how to harness the power of Azure Kubernetes Service or AKS to manage your containerized applications efficiently. You will learn practical steps for managing your containers and explore the nuances of AKS infrastructure before focusing on advanced management techniques. Let's start by gaining an understanding of the core service components used to manage containers effectively in AKS. AKS simplifies Kubernetes by handling the complexities of the control plane, allowing you to focus on deploying and managing applications. The control plane includes components like the Kube API Server, etcd, Kube Scheduler, and Kube Controller Manager, all managed by Azure. Next, you may already understand that nodes run your application workloads and are powered by Azure Virtual Machines. Each node includes crucial components such as the kubelet, kube proxy, and the container runtime, typically containered for AKS. These elements ensure your containers run smoothly and efficiently. In AKS, nodes are organized into node pools, which are groups of nodes with the same configuration. This setup allows you to scale your applications dynamically based on demand. You can create multiple node pools to support different types of workloads, such as general purpose, memory optimized, or GPU optimized tasks. Managing your resources efficiently is key to maintaining your application's performance and reliability. AKS reserves certain amounts of CPU and memory on each node to ensure the system remains healthy. To view the allocatable resources on a node, you can use this kube control command. This command provides a detailed overview of the node's resources, helping you plan your deployments. Scaling your applications in AKS is crucial for their performance and can be done both horizontally and vertically. Horizontal scaling involves adding more pods, while vertical scaling adjusts the resources allocated to existing pods. Node selectors allow you to define specific nodes for your workloads, ensuring they run in the most suitable environment. This configuration ensures the NGINX pod runs on a Linux node. Another key aspect of managing AKS is node resource groups, which handle the infrastructure for your cluster. When you create a cluster, Azure automatically sets up a node resource group to house the virtual machines, virtual networks, and storage resources. This group is essential for the smooth operation of your cluster, with Azure managing it to ensure everything runs seamlessly. Deployments are the backbone of managing applications in Kubernetes. They define the desired state of your application, including the number of replicas, container images, and resource limits. A basic deployment manifest for an Nginx server would look something like this. This manifest specifies 3 replicas of the Nginx pod with defined resource requests and limits. Another powerful tool for managing Kubernetes applications is Helm. Helm simplifies the deployment process by using charts, which are collections of files that describe a set of Kubernetes resources. You can install and manage applications using Helm charts stored locally or in remote repositories like Azure Container Registry. For example, to deploy an application with Helm, you can use this code. Helm makes it easy to update and roll back applications as needed. For applications that require persistent storage or specific scheduling, Kubernetes offers stateful sets and daemon sets. Stateful sets maintain the state and identity of pods beyond their lifecycle, making them ideal for databases and other stateful applications. Daemon sets ensure that a pod runs on every node or a subset of nodes, which is helpful for log collection or monitoring agents. For example, in a database application, each pod might have its own volume for storing data. If the pod is rescheduled, it will retain its volume and continue to use the same data. Additionally, if you're running a logging agent that collects logs from all nodes, you would use a daemon set to ensure that the logging agent runs on every node. Another brilliant Kubernetes management tool is namespaces. They allow you to organize and manage resources within your cluster and divide cluster resources between multiple users or teams. By default, AKS includes namespaces like default, kubesystem, and kubepublic, but you can create additional namespaces to suit your needs. Networking is also a critical aspect of AKS. Kubernetes uses a virtual networking layer to manage communication between pods and services. Key components include kube proxy, load balancers, and ingress controllers. Network policies help secure your applications by controlling the flow of traffic within your cluster. AKS integrates seamlessly with Azure networking services, automating many of these configurations. In conclusion, managing containers with AKS involves understanding its infrastructure, efficiently managing resources, deploying applications, and configuring networking and security. By leveraging these tools and best practices, you can ensure your applications run smoothly and securely. Many organizations struggle with deploying and scaling applications efficiently, particularly during busy periods like an e-commerce company gearing up for the holiday season. Managing these demands is crucial to ensuring your applications can be deployed and scaled adaptively to meet fluctuating needs. In this video, you'll explore container deployment and scaling with Azure Kubernetes Service or AKS and gain a thorough understanding of how to deploy and scale them effectively to handle changing demands. Let's start with deployment. As you already know, to deploy an application, you'll need to create a YAML file that defines the desired state of your deployment. On the screen, you'll notice a basic example for deploying an Nginx web server file that specifies 3 replicas of the Nginx container with defined resource requests and limits. Additionally, you should use the kubectl command line tool to apply the YAML file and deploy your application to the AKS cluster. This command tells Kubernetes to create the defined deployment with the specified number of replicas. As you know, scaling is an essential concept as it allows businesses to adapt to meet their needs. You can scale your application in AKS horizontally or vertically. Horizontal scaling involves adding or removing replicas of your containers. By increasing the number of replicas, AKS distributes the workload across more instances, ensuring high availability and efficient resource utilization. To scale your deployment horizontally, you can use the kubectl scale command. This command increases the number of Nginx replicas from 3 to 5, distributing the load across more instances. Vertical scaling, on the other hand, involves adjusting the resources allocated to each container. This means modifying the CPU and memory limits of your containers to handle more demanding workloads. To vertically scale your containers, update the resource limits in your YAML file like this. Then you can apply the updated configuration using kubectl command. This command updates the deployment with the new resource limits, ensuring each container can handle any increased load. One of the standout features of AKS is its autoscaling support, achieved through the Horizontal Pod Autoscaler or HPA. The HPA can automatically adjust the number of replicas based on CPU or memory usage. To set up autoscaling, you can use this kubectl autoscale command. This command configures the HPA to maintain CPU usage at 50%, scaling the number of replicas between 3 and 10 based on demand. In addition to the Horizontal Pod Autoscaler, AKS includes the Cluster Autoscaler. This component automatically adjusts the number of nodes in your AKS cluster. When there aren't enough resources to schedule new pods, the Cluster Autoscaler adds more nodes to the cluster. Alternatively, if nodes are underused, they are removed to save costs. To enable Cluster Autoscaler, you need to specify a minimum and maximum number of nodes in your node pool. Here's an example command using the Azure CLI. This command configures the Cluster Autoscaler to maintain the node count between 3 and 10 based on the current demand. In addition to autoscaling, monitoring is equally crucial for effective scaling. Azure Monitor offers detailed insights into your application's performance and resource usage. You can set up alerts to notify you when resources are under or overused, helping you make informed scaling decisions. In conclusion, deploying and scaling applications in AKS is straightforward when you use the right tools and techniques. You can efficiently manage your containerized applications by leveraging YAML configurations, kubectl commands, autoscaling features, and the Cluster Autoscaler. This ensures they meet changing demands and maintain optimal performance, especially during peak times. With AKS, you can handle the complexities of scaling, so your application is always ready to perform at its best. Updating your Azure Kubernetes Services or AKS is crucial. Imagine managing your organization's AKS and allowing it to become outdated. This could result in missing essential updates necessary for the smooth operation of your systems. This video will guide you through the process of upgrading AKS clusters, both manually and automatically, ensuring your applications stay up to date without any interruptions. Before diving into the how-to, you might wonder why it's essential to upgrade your AKS clusters. There are 2 main reasons. First, upgrades can bring new features, security patches, and improvements. Additionally, regular updates can ensure your applications run smoothly and securely. You should note that without regular upgrades, your cluster could become vulnerable to security threats, and you might miss out on critical patches that protect against these threats. Let's begin with discovering how to manually upgrade your AKS cluster. This involves checking the current version, then choosing the new version, and finally performing the upgrade. This process gives you complete control over when and how your cluster is upgraded. To check your current AKS cluster version, use this Azure CLI command to list the available Kubernetes versions in your region and the current version of your cluster. This will help you understand its current state and see which versions are available for upgrade. Next, use this command to display the available Kubernetes versions for upgrade in your region. This will help you choose the most suitable version for your cluster. Now it's time to upgrade your cluster to the desired version. This step may take some time, depending on the size and complexity of your cluster. Use this command to initiate the upgrade process and ensure your cluster is updated to the new version. Now let's explore automatic upgrades. While manual upgrades offer control, automatic upgrades can save time and ensure your cluster is always up to date. They minimize the effort needed to maintain your cluster and reduce the risk of running outdated versions. You can use this command to enable auto upgrades for a new or existing AKS cluster. This will ensure your cluster always runs the latest version with minimal manual intervention. Additionally, you can set the auto upgrade channel to patch, stable, or rapid depending on your update preferences. The patch channel receives the most critical security and bug fixes, making it ideal for those who prioritize minimal disruption and focus on security. While the stable channel receives stable updates that have been tested thoroughly, it's suitable for most production environments as it balances stability and new features. The rapid channel receives the latest updates quickly and includes new features and enhancements. It's best for development environments or those who want to leverage the latest features as soon as they are available. Another channel available is Node Image, which automatically upgrades the node image to the latest version. Microsoft frequently provides patches and new images for node updates, but your running nodes only receive these updates if you perform a node image upgrade. Enabling the node image channel automatically will update your node images whenever a new version is available. Additionally, with this channel enabled, Linux unattended upgrades will be disabled by default, and node image upgrades will also apply to obsolete versions as long as the minor Kubernetes version is still supported. You also have the ability to update an existing cluster automatically. This can be achieved using this command, which configures your existing AKS cluster to upgrade automatically within the specified channel. Once you have set up automatic upgrades, it's crucial to monitor the process to ensure everything runs smoothly. Regular monitoring helps verify that upgrades are occurring as expected and that your cluster remains healthy. To check the upgrade status of your AKS cluster, use this command. It provides information on the current auto-upgrade configuration and status, helping you confirm that automatic upgrades are correctly set up. In conclusion, whether you opt for manual upgrades to maintain full control or enable automatic upgrades for convenience, keeping your AKS cluster updated is crucial for security and performance. Azure provides robust tools to help you stay current with the latest features and security patches. Remember, regular upgrades ensure your applications remain efficient, secure, and capable of leveraging the latest advancements. By following these steps, you can confidently manage your AKS cluster, ensuring it always runs at its best. Congratulations on completing this first module of the course. Throughout this module, you've gained essential knowledge of crucial Azure services and now have the expertise to use and manage critical Azure resources effectively. But before you move forward, let's take a moment to recap the core topics you have learned. Revisiting this content will ensure you are fully prepared for the upcoming module quiz. You began this module with an exploration of Azure Virtual Machines, where you discussed the role of Azure VMs in cloud computing, discovering their importance in the Azure ecosystem. You also learned about various deployment methods, including OS integration and everyday challenges. Understanding what deployment means and how to deploy a VM is crucial. Following this, you covered VM sizes, storage options, and common OS challenges before exploring best practices for optimizing performance and security. Additionally, you studied several comprehensive items on Azure VMs that covered best practices for deploying and managing Azure VMs. They emphasized security, scalability, and cost optimization. To reinforce your learning, you engaged in a hands-on activity implementing virtual machine configurations according to specific requirements. Next, you explored the Azure App Service, which included the functionalities of Azure App Service, which provided you with insights into its role in hosting and managing web applications. You also learned about various deployment options, scaling strategies, and how it integrates with other Azure services. You then focused on the practical aspects of deploying web applications using Azure App Service, covering the deployment process, configuration options, and best practices for efficient application hosting. Furthermore, you studied Azure App Service's features, benefits, and use cases, and gained foundational knowledge of its capabilities. You also focused on scaling strategies for applications hosted on Azure App Service, including horizontal and vertical scaling, auto-scaling configurations, and performance considerations before participating in a hands-on activity where you configured and optimized Azure App Service. In the last part of the module, you were introduced to Azure Kubernetes Service or AKS. This included an exploration of container orchestration and how AKS simplifies managing containerized applications. You also learned the steps involved in deploying AKS clusters, with an emphasis on understanding what a cluster is before discussing the deployment steps. Following this, you covered the steps involved in managing AKS clusters. This content served as a comprehensive guide to AKS, providing documentation on cluster management, security, and best practices for deploying containerized applications while focusing on security, performance, and scalability. Additionally, several demonstrations were provided, including managing containers using AKS, deploying applications and scaling containers, and handling updates within an AKS environment. Lastly, you engaged in another hands-on activity where you had the opportunity to configure and optimize AKS for a given scenario. Great job! You've engaged with various videos, readings, and activities that encompass essential Azure resources and should now possess essential Azure knowledge that will enable you to make informed decisions in a variety of scenarios. This module has brought you one step closer to becoming a cloud support professional. Imagine you have a bunch of computers and servers and want them to talk to each other securely without anyone else eavesdropping. Essentially, that's what a virtual network or VNet does, but in the cloud. Azure Virtual Network is Microsoft's way of letting you create your own private network in the Azure cloud. It's like having your own little corner of the internet where your services can communicate safely and efficiently. In this video, you'll explore the fundamentals of Azure Virtual Network, learning about its essential components and the reasons behind its growing popularity among organizations. But first, let's take a closer look at what the Azure Virtual Network is. Azure Virtual Network is a service that provides the fundamental building blocks for your private network in Azure. It allows various Azure resources like virtual machines or VMs to communicate securely with each other, as well as the internet and on-premises networks. A virtual network is similar to a traditional one operating in your own data center. However, it brings extra benefits to the Azure infrastructure, such as scale, availability, and isolation. But why would an organization choose Azure Virtual Network? Well, there are several compelling reasons. First, Azure Virtual Network enables seamless communication between your Azure resources and the internet, ensuring your applications can reach users globally. VNets also facilitate smooth interactions between different Azure resources, allowing various application components to work together effortlessly. Additionally, they bridge the gap between your cloud and on-premises environments, simplifying connectivity with local resources. Furthermore, all resources within a VNet can communicate outbound by default, ensuring seamless internet connectivity. You can manage these connections using public IP addresses, NAT gateways, or public load balancers. For inbound communication, you can assign a public IP address or use a public load balancer. Additionally, Azure resources can communicate securely within a VNet using virtual network service endpoints to extend private address spaces to Azure services like storage accounts and SQL databases. Virtual network peering allows resources in different VNets, even across Azure regions, to communicate. Another benefit of VNets is that they act as security gatekeepers, filtering network traffic to ensure only authorized data flows through. They also optimize routing network traffic, ensuring data takes the most efficient path to its destination. VNets also filter traffic using network security groups and network virtual appliances and route traffic efficiently with custom route tables and Border Gateway Protocol or BGP routes for on-premises connections. BGP is a protocol that helps different networks share routing information to determine the best path for internet traffic. Another critical benefit of Azure Virtual Networks is integration. VNets integrate seamlessly with Azure services, simplifying the process of building, deploying, and managing your applications in the cloud. Furthermore, connecting on-premises resources to a VNet can be accomplished via point-to-site VPNs, site-to-site VPNs, or Azure Express Route. Point-to-site VPNs connect individual computers to a VNet through an encrypted tunnel, while site-to-site VPNs link on-premises VPN devices to Azure VPN gateways. Azure Express Route offers a private connection that bypasses the internet entirely. Lastly, through Azure Services integration, VNets enable private access to virtual machines or compute resources. You can deploy dedicated service instances into a VNet, use Azure Private Link, or extend a VNet to services through service endpoints. Now let's explore several critical components of an Azure VNet. Firstly, IP addresses are the unique identifiers for your resources within a VNet. You can assign public and private IP addresses to your resources, enabling them to communicate with each other and the internet. Think of them as the street addresses for your digital assets. Next, address space defines the range of IP addresses available within your VNet. You can customize the address space to fit your specific needs, ensuring you have enough IP addresses for all your resources. It's like planning a new city's layout, ensuring there's enough room for all the houses and streets. Like dividing a large room into smaller sections, subnets allow you to segment your VNet into smaller manageable parts. Each subnet can host different types of resources, and you can apply specific security rules to each one. There are also route tables, which control the flow of network traffic within your VNet. You can create custom routes to direct traffic through specific paths, optimizing the network performance and security. Think of them as the GPS for your network traffic, guiding data packets to their destinations. Next are network security groups or NSGs, which are like the bouncers of your VNet. They control inbound and outbound traffic to and from your resources. You can define rules that specify which traffic is allowed or denied, adding an extra layer of security. Last is virtual network peering. This feature lets you connect VNets to each other, even if they are in different regions. It's like creating a bridge between two islands, allowing resources in different VNets to communicate as if they were on the same network. In a nutshell, Azure Virtual Networks offer a comprehensive suite of components that work together to provide a secure, scalable, and efficient network environment. Whether you're managing traffic, securing resources, or connecting different networks, these components ensure your Azure VNet is up to the task. As organizations migrate to the cloud, understanding Azure Virtual Networks or VNets is becoming crucial for effective network design and security. In this video, you'll explore the fundamentals of Azure subnetting and network security configurations, providing practical insights for configuring virtual networks. Before we dive into the nitty-gritty of Azure subnetting, let's cover some basics. Subnetting is the process of dividing a more extensive network into smaller, more manageable subnetworks or subnets. Segmenting your network into logical parts helps you organize and secure it. Subnetting your network can offer several benefits, including improved network performance. By dividing your network into smaller subnets, you can reduce congestion and improve performance. It also offers enhanced security. Subnets allow you to implement security policies at a granular level, isolating sensitive resources. And efficient IP address management. Subnetting helps in the efficient utilization of IP addresses, preventing wastage. Now let's explore CIDR, or Classless Inter-Domain Routing. CIDR is all about flexibility in IP address allocation. Instead of sticking to the old class-based system like Class A, B, or C networks, CIDR allows us to specify the exact number of bits used for the network portion of an IP address. This is done using a suffix that follows the IP address, for example, 192.168.0.1/24. Let's break down what the different notations mean. /8 means the first 8 bits are for the network part, leaving 24 bits for host addresses. For example, 10.0.0.0/8 covers IP addresses from 10.0.0.0 to 10.255.255.255, giving you over 16 million usable IP addresses. /16 means the first 16 bits are for the network, meaning the remaining 16 bits are for hosts. For example, 172.16.0.0/16 covers a range from 172.16.0.0 to 172.16.255.255. This provides over 65,000 usable IP addresses. And /24 means the first 24 bits are for the network, leaving 8 bits for hosts. For instance, 192.168.1.0/24 covers IP addresses from 192.168.1.0 to 192.168.1.255, giving you 254 usable IP addresses. CIDR enables you to create subnets of various sizes, where size represents the number of available IP addresses, allowing for more flexible and efficient management of your network address space. You may be wondering if there are restrictions on using IP addresses in subnets. The answer is yes. Azure reserves the first 4 addresses and the last address for a total of 5 IP addresses within each subnet. For example, the IP address range of 192.168.1.0/24 has the following reserved addresses. A network address. Azure reserves this one as the default gateway. Azure also reserves this one to map the Azure DNS IP addresses to the virtual network space. And lastly, a network broadcast address. In relation to IP range, when you see an IP address with the CIDR notation, it defines a range of IP addresses. For instance, 192.168.1.0/24 covers IP addresses from 192.168.1.0 to 192.168.1.255. The range is determined by the number of bits allocated for the host portion of the address. In our example, the /24 notation means there are 8 bits left for hosts, giving us 256 possible addresses. This range includes all the addresses from the starting IP to the ending IP, making it easy to see which addresses are part of the same subnet. Now let's discuss subnet masks, which separate the network portion of an IP address from the host portion. It's usually written in the same format as an IP address, and the mask will correspond to the CIDR notation. For example, a /24 CIDR notation translates to a subnet mask 255.255.255.0. The subnet mask tells devices which part of the IP address is the network and which is for hosts. Now let's talk about securing your Azure Virtual Network. Azure provides several features to help you protect your network. First are NSGs. They are like virtual firewalls that control inbound and outbound traffic to Azure resources. You can link NSGs to subnets or individual network interfaces, applying specific rules to control the flow of traffic. Here are a couple of example rules. Allow HTTP traffic. This rule allows inbound traffic on port 80, enabling web traffic to reach your resources. Deny all inbound traffic. This rule denies all other inbound traffic by default, providing a secure baseline. Next is Azure Firewall, a managed cloud-based network security service that protects your Azure Virtual Network resources. It provides features such as threat intelligence and URL filtering. There is also VPN Gateway, which lets you securely connect your on-premises network to your Azure VNet over a secure VPN tunnel. This is useful for hybrid cloud scenarios where you must extend your on-premises network to the cloud. And Azure Application Gateway, which is a web traffic load balancer that enables you to manage web application traffic. It includes features like SSL termination, URL-based routing, and a web application firewall or WAF. Before we wrap up, you might be curious about how Azure subnetting and network security can benefit your organization. Let's explore some real-world examples that will illustrate their applications. Firstly, imagine you're managing the network for an e-commerce platform. To keep things organized and secure, you create distinct subnets for web servers, application servers, and databases. By applying NSGs, you ensure only necessary traffic flows between these layers. An Azure Firewall adds an extra layer of protection, and a VPN Gateway securely connects your on-premises data center to Azure. This setup ensures that your web servers are accessible to customers while protecting your application and database servers from direct internet access. Next, imagine you have been tasked with deploying a multi-tier application for a large corporation. You set up separate subnets for the web front end, middle-tier business logic, and back-end database. NSGs control traffic flow between these tiers, ensuring that only the necessary communication is allowed. An Azure Load Balancer distributes incoming traffic across multiple web servers, and an application gateway manages traffic routing and provides additional security features like SSL termination. This structure ensures high availability, reliability, and robust security for your application. In this video, you learned essential Azure subnetting techniques and network security configurations. These insights will help you build a secure, efficient cloud infrastructure, ensuring your applications and data are well protected while providing a seamless and reliable user experience. Cloud computing is a rapidly evolving industry, and Microsoft Azure stands out as a powerful platform for businesses of all sizes. A key to leveraging Azure effectively is understanding how to configure and manage your network infrastructure. In this video, you will be guided through the process of setting up subnets and network security groups or NSGs in Azure, which will help you to create a secure and efficient network environment for your own organization. Let's begin by exploring regions. As you may recall, the region defines the physical location of your resources. Selecting the right region is crucial when setting up Azure VNets and can profoundly impact your organization across various critical factors, including network latency. By placing resources closer to your users, you can reduce latency, ensure faster response times, and provide a better user experience. It also provides availability. Different regions may offer various levels of redundancy and availability, which directly impacts the reliability of your applications. Additionally, choosing the correct region helps ensure compliance with laws and regulations because certain industries and regions have specific regulatory requirements for data residency. And lastly, cost. Resource pricing can vary by region, so selecting a region that aligns with your budget can help optimize costs. By carefully selecting the appropriate region for your VNet, you can enhance performance, ensure high availability, meet compliance requirements, and manage costs effectively. Now let's discuss the Azure portal. Whether it's VNets, subnets, or NSGs, everything can be managed from the Azure portal. Once logged in, you control and configure all aspects of your network from this central interface. By using the search bar at the top, you can search for any resources. For example, you can search for virtual networks and manage them, or network security groups. When setting up a VNet in Azure, several key configurations need to be considered. Firstly, you need to define the address space using a classless inter-domain routing or CIDR notation. For example, 10.0.0.0/16 provides over 65,000 IP addresses. You should also choose a resource group to organize and manage your VNet and associated resources logically. Resource groups help manage costs, access control, and resource lifecycles. And the region, select the Azure region where the VNet will be deployed. The region affects the network latency and availability of regional services. Furthermore, subnets are crucial for segmenting a VNet into smaller manageable sections. They offer some key benefits, including isolation. By applying separate workloads or application tiers, you can have better security and management. Subnets also provide security. By applying different security policies and NSGs to each subnet, you can control traffic flow. And resource management. Optimize resource allocation and network performance by organizing related resources within specific subnets. While subnets offer numerous benefits, there are some challenges to be aware of. Firstly, address space management. Ensure the IP address range for each subnet does not overlap with others within the same VNet. Next, subnet size limits. The smallest subnet size is /29, providing 8 IP addresses, though only 3 are usable. And reserved addresses. Azure reserves the first 4 and the last IP addresses in each subnet for internal use, reducing the number of available IP addresses. Now let's explore the standard settings required for when creating a subnet. This involves several configuration settings. First is the IP address range. Define the CIDR block for the subnet, ensuring it falls within the VNet's address space. Additionally, the starting IP address of the subnet is derived from this CIDR block. And for the size or CIDR notation, you need to specify the subnet size. For example, 10.0.1.0/24 provides 256 IP addresses, but only 251 are usable due to reserved addresses. Additionally, you should note that NSGs can assist you and are essential for securing Azure VNets. They act as virtual firewalls, controlling inbound and outbound traffic to and from network interfaces, VMs, and subnets. There are several benefits to using NSGs, including traffic control. By defining rules, you can allow or deny traffic based on source or destination IP, port, and protocol. They also provide enhanced security. You can protect resources by applying NSG rules to subnets or individual network interfaces. And granular policies. You can create specific rules to manage traffic flow between different parts of your network. Now let's examine several common settings for configuring an NSG, including resource groups. For logical organization and management, be sure to assign the NSG to a resource group. And region, select the region where the NSG will be deployed. Typically, this should match the region of the VNet and the subnets it will protect. Lastly, NSG rules define the security policies applied to your network. The following demonstrates how it should look in the Azure portal. Inbound rules control incoming traffic to resources. Meanwhile, outbound rules control outgoing traffic from resources. Additionally, each rule includes a priority, source or destination IP ranges, port ranges, and protocols. And priority, lower numbers will have higher precedence, so careful planning is required to avoid conflicts. Similarly, outbound rules would follow the same pattern for outgoing traffic in NSGs. Grasping the essential settings and configurations for VNets, subnets, and NSGs is vital for crafting a secure and efficient Azure network. Effective segmentation of your network using subnets, combined with the robust security measures provided by NSGs, not only optimizes resource management, but also significantly enhances overall security. If you were an IT manager in an organization that had recently decided to migrate its operations to Azure, your primary concern would be to ensure that your customer data, payment information, and internal communications remain secure. With the shift to cloud infrastructure, securing network traffic will be your top priority. As more organizations move their operations to the cloud, the demand for robust network security measures has never been greater. Whether you are an experienced cloud architect or just starting in the profession, mastering the best practices for securing network traffic within Azure Virtual Networks or VNets is crucial. So how can you ensure that your Azure VNet is secure? In this video, you'll explore several best practices that will enhance your digital defenses. Let's begin by exploring how Azure Virtual Network works as the foundation of your cloud infrastructure. Just as you wouldn't build a house on shaky ground, you shouldn't skimp on your VNet design. Remember to keep the following key principles in mind. Firstly, segmentation is key. Remember to divide your network into multiple VNets based on your organizational structure and security needs. This approach helps contain potential breaches and gives you more granular control over network traffic. Next, leverage service tags. Azure's service tags are like shortcuts for groups of IP addresses. Using them instead of specific IP ranges can simplify your network management and reduce the risk of configuration errors. Additionally, distributed denial of service or DDoS protection is essential. By enabling Azure DDoS protection standard, you will have a bouncer at the door of your digital nightclub that will keep out unwanted traffic. Lastly, remember that firewalls are your friends. By deploying Azure Firewall for centralized traffic filtering, you will have a super smart security guard that monitors traffic across multiple VNets. Now let's explore the hub and spoke model. Imagine your network is a wheel. The hub and spoke model is precisely what it sounds like, a central hub connected to multiple spokes. You implement it by creating a central hub VNet. This VNet is the central point connecting to on-premises networks and hosting shared services. It simplifies management and enhances security. Next, deploy spoke VNets. These VNets relate to specific departments or workloads and connect to the central hub, ensuring efficient communication and resource sharing. You then connect with VNet peering to establish low-latency, high-bandwidth connections between your hub and spoke VNets, ensuring seamless communication and data transfer. Next, centralize security by hosting key security services such as firewalls and monitoring tools in your VNet hub. This centralization enhances security and simplifies management. And finally, control internet access by routing internet-bound traffic from spoke VNets. Through the hub VNet, you can apply consistent security policies and monitor traffic effectively. Now let's explore subnets. You might remember that subnets allow you to segment your VNet into smaller manageable parts. They act like the rooms in your digital house. You can arrange them effectively by planning your subnet sizes carefully. Azure recommends a minimum of /27 for most workloads, which will ensure you have enough IP addresses for your resources. You should also ensure you have dedicated spaces by creating separate subnets for critical services like Azure Firewall or VPN Gateway. This will isolate these services and enhance security. Next, implement service endpoints to extend your VNet's private space to Azure PaaS services. This will improve security by keeping traffic within Azure's network. Also, try leveraging Private Link, which will allow private access to Azure and partner services, reduce exposure to the public internet, and enhance security and privacy. And apply subnet-level NSGs at the subnet level to provide a security baseline for all subnet resources, ensuring consistent security policies. Lastly, as you are now aware, NSGs control inbound and outbound traffic to your network resources. Use them effectively by adhering to the principle of least privilege. Allow only the minimum necessary traffic by starting with the default deny rule and adding specific allow rules as needed. This approach minimizes potential attack vectors. Next, use application security groups. Group VMs and define security policies based on these groups. This strategy simplifies management and enhances security. And carefully prioritize rules. NSG rules are processed in order, so place specific rules before general ones. This ensures that critical rules are applied first. You should also conduct regular reviews. Document and review your NSG rules regularly to ensure they remain relevant and effective. This practice helps maintain a secure network. Next, troubleshoot with Network Watcher. Use Azure's built-in Network Watcher tools to validate and troubleshoot your NSG rules. This helps quickly identify and resolve issues. And lastly, control traffic in both directions. Implement both inbound and outbound rules to manage traffic effectively. This ensures comprehensive security for your network. Securing your Azure Virtual Network is not a one-time task, but an ongoing process. Regular reviews, updates, and vigilance are vital to maintaining a robust security posture. By following these best practices, you'll be well on your way to creating a secure, efficient, and resilient cloud network infrastructure. Imagine working for an organization whose application experiences a surge in traffic during busy periods. The single server hosting the application struggles to keep up, causing slow response times for customers. Instead of continuously adding more network capacity, processors, disk resources, and RAM, which is costly and inefficient, you can implement load balancing to manage the traffic effectively. Load balancing is a brilliant service that distributes incoming traffic evenly across multiple servers, ensuring no single server becomes overwhelmed. This approach allows a pool of servers with moderate resources to handle the traffic more efficiently than a single high-performance server. In this video, you'll explore Azure Load Balancer, learning about its features and how it can optimize your application's performance by distributing traffic evenly across your servers. Let's start by exploring how Azure Load Balancer works. It's a high-performance, ultra-low latency load balancing service for all UDP and TCP protocols. It is designed to handle millions of requests per second, ensuring your application remains highly available. Azure Load Balancer is zone redundant, providing high availability across different zones. It ensures optimal network performance through the following ways. First, load balancing rules determine how traffic is distributed to the instances in the backend. And health probes check the health of backend instances, ensuring traffic isn't directed to unhealthy ones. In Azure, you can deploy both public and internal load balancers. A public load balancer maps the public IP and port of incoming traffic to the private IP and port of the virtual machine or VM and handles the reverse for response traffic. By applying load balancing rules, you can distribute specific traffic types across multiple VMs or services, such as spreading web request traffic across various web servers. An internal load balancer distributes traffic to resources inside a virtual network. Azure restricts access to the front-end IP addresses of a load-balanced virtual network, so front-end IP addresses and virtual networks are never directly exposed to an internet endpoint, meaning an internal load balancer can't accept incoming traffic from the internet. But when is the best time to use a load balancer? Azure Load Balancer is best suited for applications that require uptime and high performance under traffic spikes. For example, maybe you need to distribute load during high or unpredictable traffic to prevent server overload, or you need to scale your application by adding servers and ensuring even traffic distribution. Additionally, you may need to maintain availability by redirecting traffic to healthy servers during failures. You may also need to improve response times by managing request distribution based on server load. And lastly, reduce latency and improve user experience by routing traffic to the nearest or least loaded server. However, when is a load balancer not appropriate? Azure Load Balancer is not suitable when you have a web application that doesn't require load balancing running on a single infrastructure as a service VM instance. For example, suppose your web application only receives a small amount of traffic and the existing infrastructure already competently deals with the existing load. In that case, there's no need to deploy a backend pool of VMs or use load balancer. There are several alternatives to load balancer that Azure provides, including Azure Front Door, Azure Traffic Manager, and Azure Application Gateway. Firstly, Azure Front Door works as an application delivery network that provides global load balancing and site acceleration service for web applications. It offers capabilities for your application, including path-based routing, fast failover, a web application firewall, and caching to improve performance and high availability. This option should be chosen in scenarios such as load balancing a web app deployed across multiple Azure regions. Next is Azure Traffic Manager, a DNS-based traffic load balancer that allows you to distribute traffic optimally to services across global Azure regions while providing high availability and responsiveness. Because Traffic Manager is a DNS-based load balancing service, it loads balances only at the domain level. Because of common challenges around DNS caching, it can't fail over as quickly as Front Door. Last is Azure Application Gateway, which provides an application delivery controller or ADC as a service. You can use it to optimize web farm productivity by offloading CPU-intensive TLS and SSL termination to the gateway. SSL and TLS termination refers to the process of decrypting encrypted traffic at the load balancer or gateway level. The application gateway operates within a region rather than globally. Azure Load Balancer is a crucial networking service in Azure, distributing incoming traffic across multiple resources to enhance performance and availability. For aspiring IT professionals, understanding Azure Load Balancer is key to building scalable and resilient cloud applications. This video offered essential insights into its functionality, diverse use cases, and comparisons with other Azure load balancing options, equipping you with valuable knowledge for optimizing cloud infrastructure. By now, you're aware that Azure Load Balancer is a high-performance, low-latency solution for distributing network traffic in the Azure cloud environment. Like all other load balancers, it uses a variety of algorithms to route incoming requests effectively. These algorithms, such as round-robin and least connections, help ensure optimal resource use and balanced workloads. In this video, you will further explore Azure Load Balancer, discovering its distribution mechanism and some of the common algorithms that it uses to manage traffic flow. Additionally, you will examine the technical details of its operation, including hashing methods and interactions with backend resources to ensure optimal performance and scalability for your applications. Let's kick things off by talking about some common load balancer algorithms. First is round-robin, which works by distributing requests sequentially across the server pool. It's straightforward, but doesn't consider server load or capacity. Next is least connections. Here, traffic goes to the server with the fewest active connections, which helps balance the load more effectively. There's also weighted round robin, which is similar to round robin, but servers get assigned weights based on their capacity or performance. Next is IP hash. This method uses the client's IP address to decide which server should handle the request, ensuring the client consistently connects to the same server. And last is health-based. This algorithm looks at the current health and performance of backend servers, routing traffic only to those that are functioning correctly and can handle the load. Now, let's focus on the Azure Load Balancer algorithm, which uses a more sophisticated approach. Known as the 5-tuple hash algorithm, it operates behind the scenes by employing a 5-tuple hash to distribute inbound flows. It's called 5-tuple because it uses 5 specific parameters to create the hash. This tuple consists of a source IP address, source port, destination IP address, destination port, and IP protocol number. This algorithm creates a hash based on these 5 parameters to map flows to available servers in the backend pool. The Azure Load Balancer offers several benefits, including Session Affinity Mode, which uses either a 2-tuple or 3-tuple based distribution. This mode can help maintain consistent connections between clients and specific backend servers. This mode has 2 configuration types. Client IP, which is a 2-tuple, specifies that the same backend instance handles successive requests from the same client IP address. And Client IP and Protocol, which is a 3-tuple, specifies that the same backend instances handle successive requests from the same client IP address and protocol combination. Next, Azure Load Balancer operates at Transport Layer 4 of the Open Systems Interconnection or OSI model. The OSI model is a conceptual framework that describes how data is transmitted over a network using 7 distinct layers. Layer 4, also known as the transport layer, is all about efficiently moving data from one point to another, no matter what that data is. That's why the load balancer can handle any TCP or UDP traffic. It doesn't need to know what's in the messages. It just ensures they arrive where they're supposed to go. The load balancer also doesn't terminate or originate flows. Instead, it rewrites the headers of TCP or UDP flows when directing traffic to backend instances. It's also important to note that Azure Load Balancer incorporates health-based routing through its Health Probe feature. These include regular health checks being performed periodically by sending health probe requests to all backend instances. Backend instances also become eligible to receive new traffic flows only when the load balancer's health probe indicates they are healthy. Additionally, if a backend instance fails to respond to a health probe, the load balancer automatically removes it from rotation, preventing traffic from being sent to unhealthy cases. And administrators can also configure the protocol, port, and path for health probes, as well as the probe interval and unhealthy threshold. Azure Load Balancer also offers transparency to the client and the backend pool. It preserves the source IP address of incoming requests, allowing backend servers to see the actual client IP. You should also note that the load balancer doesn't interact with the TCP payload or provide TLS offload. This allows for comprehensive encrypted scenarios where TLS connections end directly on the VM. The capacity for TLS session keying is determined by the type and number of VMs in the backend pool. Lastly, responses to inbound flows always come directly from a backend VM, not the load balancer itself. By combining the 5-tuple hash algorithm with health-based routing, Azure Load Balancer ensures high-performance, low-latency load balancing. This efficient distribution of traffic across healthy backend instances makes it ideal for various applications and scenarios within the Azure cloud environment, offering both performance and reliability. Suppose you managed a web application for your organization that was gaining popularity and experiencing increased traffic. How would you ensure the application could handle this increased load and maintain high availability? In this scenario, you could distribute incoming traffic across multiple virtual machines or VMs using Azure Load Balancer. By correctly configuring load balancing rules, you can efficiently distribute traffic and keep your application responsive. Azure Load Balancer is key to spreading incoming network traffic across multiple VMs. In this video, you'll walk through the different load balancing rules, concepts, and configuration options in Azure Load Balancer, ensuring your network traffic is delivered effectively. Let's start by discussing the types of load balancers available. Azure offers two, a basic load balancer and a standard load balancer. A basic load balancer is suitable for small-scale, non-mission critical applications, while a standard load balancer offers enhanced features and is suitable for production workloads. Both of these load balancers support various rules for configuring traffic to the backend pool. These include 5 main types: load balancing rules, inbound NAT rules, outbound NAT rules, high availability port rules, and health probes. Let's look at each one in a little more detail. First are load balancing rules, which are for inbound traffic only. They determine how incoming traffic is distributed among the instances in the backend pool. A load balancing rule maps a given front-end IP configuration and port to multiple backend IP addresses and ports. For example, you can use a load balancer rule for port 80 to route traffic from your front-end IP to port 80 of your backend instances. Next are inbound network address translation or NAT rules, which forward incoming traffic sent to a front-end IP address and port combination to a specific virtual machine in the backend pool. Port forwarding uses the same hash-based distribution as load balancing. Next, let's discuss outbound rules that configure outbound NAT for all virtual machines or instances identified by the backend pool. This rule enables instances in the backend to communicate to the internet or other endpoints. You should be aware that the basic load balancer doesn't support outbound rules. Now let's move on to high availability or HA rules. An HA port rule is a load balancer rule configured with protocol all and port 0. This rule enables a single rule to load balance all TCP and UDP flows that arrive on all ports of an internal standard load balancer. The system then makes the load balancing decision for each flow based on the following 5-tuple connection: a source IP address, source port, destination IP address, destination port, and protocol. These HA port load balancing rules help you with critical scenarios such as high availability and scale for network virtual appliances or NVAs inside virtual networks. This brilliant feature can help when a large number of ports must be load balanced. Our final rule is a health probe, which assesses the health status of instances in the backend pool. You can configure a health probe during the load balancer's creation. It will then check whether an instance is healthy and capable of receiving traffic. Additionally, you can specify the unhealthy threshold for your health probes. So, when a probe fails to respond, the load balancer stops directing new connections to the unhealthy instances. However, existing connections will remain unaffected by a probe failure. This connection will continue until the application ends the flow, idle timeout occurs, or the VM shuts down. It's important to note that the basic load balancer doesn't support HTTPS probes. If your application needs secure health checks, you'll need to use the standard load balancer. Knowing this helps you choose the right load balancer type for your needs. In conclusion, setting up load balancing rules in Azure is vital to maintaining the reliability and availability of your applications running on virtual machines. With the right configuration, you can ensure your applications remain responsive and operate smoothly even as demand fluctuates. Azure Load Balancer is essential for effectively managing cloud infrastructure and handling increased traffic with ease. Just like a building's security system, Identity and Access Management, or IAM, controls who can access cloud resources, safeguarding sensitive information. In the digital age, protecting data and ensuring only authorized users, machines, and applications access the right resources is crucial. This is where IAM comes into play. It can secure and manage system interactions efficiently. In this video, you'll explore the basic concepts and core functions of IAM. You'll also discover the processes and standards IAM uses to ensure the secure and efficient management of digital identities and access to resources. Let's start by exploring some of the basic IAM concepts. First, resources. These are digital assets requiring protection and controlled access, such as files, databases, web applications, APIs, devices, or services. Next, users. A user is someone, represented by a digital identity, who needs access to resources. Users can be customers, partners, members, or employees. Digital identities can also represent machines, applications, or workloads. Third, authentication. Authentication verifies the identity of a user or entity before granting access using credentials like passwords, biometrics, or tokens. And finally, authorization determines the access level and actions an authenticated user or entity can perform. At the heart of IAM lies the concept of digital identity. Digital identity is a collection of unique identifiers representing users or entities in a computer system. These identifiers include email addresses, sign-in credentials, government-issued IDs, and more complex attributes like MAC or IP addresses. The three types of digital identities are human identities. These include internal users like employees and external users like customers, consultants, vendors, and partners. Workload identities. These cover software workloads such as applications, services, scripts, and containers. And device identities. These encompass desktop computers, mobile phones, Internet of Things or IoT, sensors, and IoT-managed devices. Understanding these identity types is crucial for securely and efficiently managing identities. Now let's explore authentication and authorization further. Authentication and authorization are often confused with each other, but they serve very distinct functions. Authentication verifies an identity, proving you are who you say you are, whereas authorization grants an authenticated party permission to do something, like allowing an employee to access specific files. In the secure building example, authentication verifies your identity using your keycard, and authorization unlocks the door to grant access after authentication. Authentication typically requires the use of credentials like passwords, biometric data, or one-time passcodes. The industry is moving towards passwordless authentication technologies like multi-factor authentication or MFA, requiring more than one piece of evidence like a security token or fingerprint, and single sign-on or SSO, allowing authentication once to access multiple resources without needing to sign in to each system separately. On the other hand, authorization validates and determines access levels for authenticated users, machines, or software components. It defines what a verified user or entity can do within a system. Within IAM, authentication and authorization standards ensure secure and proficient processes for identifying and granting access to resources. Widely used standards include OAuth 2.0, which allows applications to access resources on behalf of a user using tokens. OpenID Connect, or OIDC, is an authentication layer on top of OAuth 2.0. JSON Web Tokens, or JWTs, securely transmit information as a JSON object. Further standards include Security Assertion Markup Language, or SAML, which exchanges authentication and authorization data using XML. System for Cross-Domain Identity Management, or SCIM, which simplifies user identity management across cloud-based applications. And Web Services Federation, or WSFed, which secures the exchange of identity information between different trust domains. IAM uses policies and technologies to provide verified users or entities with secure access. These policies and technologies include identity management, used to create, store, and manage users' digital identities; identity federation, used to enable access across systems using existing credentials; and provisioning and deprovisioning, used to manage the user account lifecycle. The policies and technologies further include authentication and authorization, used to validate identities and grant access rights; access control, used to define and enforce appropriate access to resources; and finally, reporting and monitoring, which is used to generate reports and activity logs for compliance and security. A final aspect of IAM that you should understand before exploring how IAM works is the role of identity providers. Identity providers, or IDPs, like Microsoft Entra ID, Google, Amazon, and Auth0 are crucial components of IAM systems. IDPs play a pivotal role in IAM by creating, maintaining, storing, and managing identity information. IDPs offer authentication, authorization, and auditing services, centralizing policies and processes to monitor user behavior and reduce attacks. Now let's explore how IAM works. IAM orchestrates a series of processes to ensure the secure and efficient management of digital identities and access to resources. The high-level authentication and authorization process is as follows. First, the user initiates an authentication request. Then, the identity provider verifies the user's credentials and sends an ID token to the client application. Next, the user consents, and the identity provider sends an access token to the client application. Then, the access token is used to request resources. And finally, the identity provider validates the access token and grants access to the requested resources. Let's summarize what you've learned in this video. IAM manages access to digital resources through authentication and authorization, helping protect data and maintain secure systems. IAM employs standards, policies, and technologies within the authentication and authorization processes to provide verified users with the appropriate level of secure access. Understanding these essential concepts and how they relate to Azure IAM will help you provide secure and efficient access to resources in a digital environment. Previously, you learned about Azure Identity and Access Management, or IAM, and how it controls access to cloud resources. Another crucial part of access control is managing users, groups, and roles to maintain secure access to digital resources. In this video, you'll explore how to manage users, groups, and roles to enhance effective access control in Azure. Let's start with exploring managing users. Users are individuals or entities represented by digital identities who need access to resources. Managing users involves creating, updating, and deleting user accounts and managing access levels. In Azure, user accounts can be managed through Microsoft Entra ID, a comprehensive identity and access management service that provides secure access to resources. In Microsoft Entra ID, you can create users manually or use automated processes such as integrating with an on-premises Active Directory. Once users have been created, they are assigned unique identifiers and sign-in credentials to track and manage access. Let's explore creating a user in Microsoft Entra ID. First, open the Azure portal and search for Microsoft Entra ID. Next, expand the Manage drop-down menu and select Users. On the Users page, select New User and then Create a New User. On the Create New User pane, enter the required information for the username, name, and password. Once you have completed the required information, on the Review and Create tab, select Create to add the new user. Your new user is now available in Microsoft Entra ID. You can also update user information such as contact details, job titles, and department assignments. Keeping user information current is vital for accurate access management and efficient communication within the organization. Regular updates also ensure that access permissions align with users' roles and responsibilities, minimizing security risks. When users leave or no longer need access, their accounts should be deleted promptly to prevent unauthorized access. Deprovisioning users, which involves revoking access rights and removing user accounts, is a critical security measure to ensure that former employees or contractors cannot access sensitive data. Automated deprovisioning processes can help ensure access is revoked immediately when a user leaves the organization. Next, let's discuss managing groups. Users who need similar access to resources can be organized into groups to manage their resource access effectively. Managing groups simplifies the process of assigning and managing permissions, making it easier to maintain security and efficiency. Groups can be created based on roles, departments, or projects. You might have groups for teams like development, marketing, and sales, each with specific access needs. In Microsoft Entra ID, there are two primary types of groups: security groups and distribution groups. Security groups manage access to resources, while distribution groups are used for email communication. It's important that you create the right type of group based on its purpose. Let's explore creating a group in Microsoft Entra ID. First, open the Azure portal and search for Microsoft Entra ID. Next, expand the Manage drop-down menu and select Groups. On the Groups page, select New Group. On the Create New Group pane, enter the group type, name, and description. 4 Microsoft Entra roles can be assigned to the group. select No. This means that this group will not have any administrative roles assigned to it. For this example, no members have been assigned. Select Create to create the group. Now that your group is created, you can add users to the group. Users can be added to groups based on their roles and responsibilities. This group-based approach simplifies permission management and ensures consistency. On the Groups page, select the group to which you want to add users. You can also search for the group by entering its name in the search field. Please note that you might need to refresh the page for any newly created groups to appear in the list. Next, expand the Manage drop-down menu and select Members. Select Add Members. In the Add Members pane, search for the user by typing their name or email address. Select the checkbox next to the user in the search results and then select to confirm. You can also select multiple users. Group membership can be managed manually or through dynamic membership rules, automatically adding users based on attributes like job title or department. Finally, groups can be updated to reflect organizational or project changes. For example, if a project team increases or decreases, you can adjust the group membership accordingly. Unused or obsolete groups should be deleted to maintain an efficient directory. Furthermore, regular reviews of group memberships will help you prevent unauthorized access and maintain security. Now let's briefly discuss managing roles. Within Azure IAM, roles are managed through Role-Based Access Control or RBAC. RBAC ensures users have necessary access levels by assigning permissions based on roles, minimizing security risks. These roles, such as Reader, Contributor, and Owner, have predefined permissions based on job functions and responsibilities. You can also create custom roles for specific projects or applications with unique access requirements. Roles can be assigned to individual users or groups. This ensures all members inherit the same permissions, reducing administrative overhead and maintaining consistent access permissions. Furthermore, regular review and updating of role assignments ensure alignment with job functions and organizational changes. This proactive approach maintains security and efficiency by removing access for users who no longer need it, keeping permissions up to date and relevant. You will learn more about RBAC later. Effective management of users, groups, and roles is essential for maintaining secure access to Azure resources. By leveraging Microsoft Entra ID and implementing best practices, you can ensure your IAM strategy supports organizational security and efficiency. Previously, you learned about the fundamental concepts of Azure IAM and how to manage users and groups. You were also introduced to Role-Based Access Control, or RBAC, a crucial part of securing access to digital resources in Azure. Where IAM is like the overall security system that manages access to a secure building, RBAC is the function that assigns specific access rights based on a person's role. Almost like a manager might have access to all office areas in a building, while a maintenance worker only has access to technical rooms. In this video, you will explore RBAC further and how to implement it in Azure. Let's start by discussing a few RBAC core concepts. RBAC is a powerful feature that allows you to manage who has access to Azure resources, what they can do with those resources, and what areas they have access to. RBAC is essential for managing permissions and access to resources within an organization. By regulating access based on user roles, RBAC ensures users have the necessary permissions to perform their tasks while minimizing security risks. Aspects that form part of fine-grained access management include role assignments, role definitions, and scopes. Let's discuss these aspects further. A role assignment involves giving specific permissions to a person, group, or application, also known as a security principal, so they can access certain Azure resources. This is done by assigning a role which defines what they can do to the person, group, or application within a specific area of Azure. For example, you can assign the contributor role to a user at the resource group level, giving them permissions to manage all resources within that group. Next, a role definition is a collection of permissions. It is also sometimes referred to as a role. A role definition lists the actions that can be performed, such as read, write, and delete. Azure includes several built-in roles that you can use. For example, the reader role grants read-only access to resources, while the contributor role grants read and write access, but not the ability to grant access to others. Finally, scopes are the set of resources that access applies to. Examples of scopes are an entire subscription, a specific resource group, or an individual resource. Scopes help you manage permissions by limiting the range of resources a role assignment applies to. For example, you can give a user permission to manage only one specific resource group rather than everything in your Azure account. This way, they can work on the resources in that group without affecting other groups or the entire account or subscription. Let's explore how to assign a role to a user in Azure. First, open the Azure portal in your web browser and sign in with your Azure account. Next, navigate to the resource you want to assign a role to. This step will determine the appropriate scope, which can be a subscription, resource group, or specific resource. For example, to assign a role at the subscription level, go to the Subscriptions page and select your subscription. Then, in the Selected Resources menu, select Access Control IAM to open the IAM page. Select Add and then Add Role Assignment. On the Role tab, select Privileged Administrator Role and search for the role you want to assign, for example, Contributor. Next, select the Members tab, and for Assign Access to, select User, Group, or Service Principal. Next to Members, choose Select Members. In the Select field, type the name of the user, group, or service principal you want to assign the role to and select them. Finally, select Review and Assign to apply the role assignment. You have now successfully assigned a role to a user at the subscription scope. Next, let's briefly discuss built-in roles and custom roles. Azure provides several built-in roles that you can use. Some of the most common built-in roles are Owner, which provides a user with full access to all resources, including the right to delegate access to others. Then, Contributor, which allows a user to create and manage all types of Azure resources, but does not grant the ability to delegate access. And Reader, which allows a user to view existing Azure resources. In addition to built-in roles, Azure allows you to create custom roles tailored to your organization's specific needs. You will learn more custom roles later. Lastly, let's discuss a few of the best practices for implementing custom roles. Firstly, use built-in roles whenever possible. Built-in roles are designed to cover common scenarios and are regularly updated by Microsoft. Next, the principle of least privilege should be applied by only granting users the minimum permissions they need to perform their tasks. This reduces the risk of accidental or malicious changes. Thirdly, regularly review your role assignments to ensure they are still appropriate for the user's current job functions. And use Azure Activity Logs and other monitoring tools to track changes in role assignments and ensure compliance with your organization's policies. In conclusion, implementing role-based access control, or RBAC, in Azure is a powerful way to manage access to your resources. By understanding and using RBAC effectively, you can ensure that users have the appropriate level of access they need while maintaining security and compliance. So far, you've learned about managing users and groups and how to assign specific permissions to users based on their roles. In this video, you will explore how to create custom roles and assign permissions to users based on their roles in Azure. Let's start by discussing a few core concepts relating to custom rules. To bring it back to the example of managing access to a secure building, imagine having to load specific permissions on the key cards of a particular project team that only authorize access to the project's designated workspace and meeting rooms. Similarly, custom roles in Azure enable you to tailor a set of permissions according to your specific requirements, ensuring a more precise and secure access control to digital resources. Unlike built-in roles, custom roles offer the flexibility to include only the permissions you need, providing a more granular level of control over resource access. A custom role definition also includes the actions that can be performed, such as read, write, and delete. These permissions are specified using Azure Resource Manager or ARM actions, which can be as broad or as specific as needed. Custom roles are defined using a JSON template, which includes properties like the role name, description, permissions, and assignable scopes. A JSON template can be illustrated like this, which has a custom role named Custom Role Example. This allows read and write actions on storage accounts within a specific subscription. Assignable scopes specify where the custom role can be assigned, such as at the subscription, resource group, or resource level. This helps you manage permissions effectively across different levels of your Azure environment. Let's explore how to create a custom role in Azure. First, open the Azure portal in your web browser and sign in with your Azure account. Next, navigate to the subscription, resource group, or resource where you want to create the custom role and select Access Control IAM in the left-hand menu. Select Add and then Add Custom Role. On the Basics tab of the Create a Custom Role page, enter a custom role name and description. Leave the baseline permissions option set to start from scratch. For the purposes of this example, don't make any changes on the Permission tab. Next, on the Assignable Scopes tab, select Add Assignable Scope and select the appropriate scope from the list. This is where you specify where the custom role can be assigned, whether it be a subscription, resource group, or individual resource. Once this is done, the next step is to edit the JSON template. First, select the JSON tab and choose Edit. In the Actions section, add the permissions you want to add to the custom role. For example, Microsoft.storage/storage-accounts/list-keys/action. This permission allows viewing the access keys for the storage account. In this example, the permissions added are for read-only access to the resources. Once you have added the permissions, select Save. Finally, select the Review and Create tab, and once you have reviewed the settings, choose Create to create the custom role. The custom role has now been created. Once the custom role is created, wait for a few minutes and then you can assign it to a user, group, or service principal. Next, let's explore how to assign a custom role to a user in Azure. Navigate to the subscription, resource group, or specific resource where you want to assign the role and select Access Control IAM in the left-hand menu. Select Add and then Add Role Assignment. On the Role tab of the Add Role Assignment page, under Job Function Roles, search for the role you created. Next, select the Members tab, and for Assign Access to, select User, Group, or Service Principal. Next to Members, choose Select Members. In the Select field, type the name of the user, group, or service principal you want to assign the role to and select them. Finally, select Review and Assign to apply the role assignment. You have now successfully assigned a role to a user at the subscription scope. Lastly, let's discuss a few of the best practices for implementing custom roles. First, ensure that custom roles grant only the permissions necessary for users to perform their tasks. This minimizes security risks and potential misuse. Next, periodically review custom roles and their assignments to ensure they remain aligned with organizational needs and security policies. Third, clearly name and describe custom roles to make it easy to understand their purpose and permissions. And before deploying custom roles in a production environment, test them in a development or staging environment to ensure they work as expected. In conclusion, creating and assigning custom roles in Azure provides a flexible and secure way to manage access to resources. By tailoring permissions to meet your organization's specific needs, you can ensure that users have the appropriate level of access they need while maintaining security and compliance. Congratulations on completing the next module of this course. Throughout this module, you examined the intricacies of Microsoft Azure as it relates to networking. Before moving forward, let's recap the core topics you have covered to ensure you're ready for the upcoming module quiz. You began with an exploration of Azure Virtual Networks. Here's a quick rundown of what you covered. After learning about the basics of virtual networks, you explored various subnetting techniques and network security configurations. This demonstrated the importance of subnetting in network design and how to configure network security to protect your resources. Next, you examined advanced configuration options for subnets and NSGs. This included a study of network security groups, or NSGs, and how they can be configured to control inbound and outbound traffic. Following this, you read about the best practices for securing network traffic. This covered the various strategies for securing traffic within Azure Virtual Networks, which ensures that your network remains safe from threats. Lastly, you covered network concepts, configuration steps, and troubleshooting, which provided a thorough understanding of how basic and advanced network concepts are developed. In addition, you were guided through practical configuration steps and learned methods for troubleshooting common issues. The next part of the module moved on to load balancing. Here you explored the benefits of the Azure Load Balancer and how using Azure Load Balancer to distribute traffic across multiple servers improves application availability and reliability. You also discussed load balancing algorithms and configuration settings, including various algorithms used by Azure Load Balancer and the necessary configuration settings to optimize performance. Following this, you learned about configuring load balancing rules, including how to set up rules that define how incoming traffic should be distributed to the backend pool. Then you examined foundational load balancing concepts, configuration steps, and techniques for troubleshooting common issues. Lastly, you picked up some best practices for optimizing application delivery. You became aware of strategies that enhance the delivery and performance of applications using Azure Load Balancer, which can ensure your applications run smoothly and efficiently. The final part of the module focused on Identity and Access Management, or IAM, in Azure. You found that, much like controlling access to secure areas in a building, IAM ensures that only authorized users, machines, and applications access the right resources at the right time. This involves first authenticating an identity and then authorizing the level of access an authenticated user, machine, or software component has to a specific resource. You then discovered how to manage users, groups, and roles using Microsoft Entra ID. Here you explored the process of creating, updating, and deleting user accounts and assigning appropriate access levels to ensure security and compliance. You also learned about creating and managing groups to efficiently grant users with similar resource access requirements the appropriate permissions and streamline administration tasks. Next, you explored how to implement role-based access control, or RBAC, in Azure, and how it allows you to assign roles to users and groups based on their job responsibilities. You learned how RBAC ensures that the right users have the right permissions to perform their tasks, reducing the risk of unauthorized access. Lastly, you explored how to implement custom roles in Azure and the best practices for creating custom roles and assigning access permissions to meet specific organizational needs. You discovered how custom roles enhance both security and operational efficiency by providing granular control over resource access. Throughout this module, you engaged with various videos, readings, and activities that helped you build a foundation for understanding networking in Azure. Before you take on the module quiz, feel free to revisit any topics that you feel unsure about and get yourself as prepared as possible. You're doing great, so keep going.
Picture this. As a cloud support professional at your company, you are responsible for ensuring that the resources within your cloud environment are well managed. However, manual tasks for setting up development environments through the portal have proved to be tedious and error-prone. You're eager to improve your workflow and reduce errors, so you dive into learning how Azure Command Line Interface, or CLI, can streamline these tasks. In this video, you'll explore the benefits of Azure CLI, understand why organizations prefer it over the Azure portal, and learn how to install it on different operating systems. Azure CLI is a cross-platform tool that allows you to easily manage and interact with Azure resources like virtual machines, storage accounts, and databases using simple commands, saving you time. It's available for Windows, Mac OS, and Linux, offering a flexible and efficient way to handle tasks such as creating virtual machines and managing storage accounts. Now, let's unpack the benefits of using Azure CLI to manage Azure resources. For starters, it allows for the automation of repetitive tasks like provisioning virtual machines, configuring networks, and deploying applications. This reduces errors and increases efficiency. Imagine automating a daily task that previously took hours, now done in minutes. Azure CLI provides flexibility, as you can customize workflows to meet specific resource management needs. Additionally, you can scale resources up and down as needed, making this tool ideal for large-scale deployments. Thanks to its speed and efficiency, it also cuts down on deployment times and boosts productivity, letting you focus on high-priority tasks. Plus, Azure CLI lets you ensure consistent resource configuration and deployment, improving reliability. For instance, it makes tasks like setting up multiple virtual machines with the same settings simple, making everything more efficient and reducing the chance of errors. Furthermore, its scripting capabilities allow complex tasks to be reproduced and shared with team members, streamlining workflows and enhancing collaboration. If you need help, its extensive documentation and community support make Azure CLI easy to learn and use, even if you're new to Azure. So far, these features sound great, but like many other cloud support professionals, you might be wondering, how well does Azure CLI integrate with other Azure services? It integrates seamlessly with various Azure services, such as Azure DevOps, Azure Monitor, and Azure Security Center, providing a comprehensive management experience. It also works effectively with Azure's Role-Based Access Control, or RBAC, ensuring that users have access only to necessary resources, thereby enhancing security and compliance. Finally, its integration with auditing and logging capabilities across Azure services offers transparency and accountability, as all actions are tracked and recorded. To summarize these benefits, by utilizing Azure CLI, your organization can achieve streamlined resource management, improved efficiency, reduced costs, enhanced reliability, and save time. Now that you understand the benefits of Azure CLI, let's get it installed on your machine. First, download the Azure CLI installer from the official Microsoft link by selecting the latest MSI of the Azure CLI 64-bit version. Once downloaded, run the installer and follow the prompts to complete the installation. This process is user-friendly and guides you through each step. After installation, open a new command prompt or PowerShell window. Type AZ space -- version and press Enter to verify the installation. Great work! You have successfully installed Azure CLI on your Windows machine. Now let's move on to macOS. To install it on macOS, you can use Homebrew, a popular package manager for macOS. First, open your terminal by searching for Terminal in Spotlight, or by going to Applications, then Utilities, and selecting Terminal. Once open, run the following commands: brew update and brew install Azure-CLI. This method is quick and efficient, leveraging Homebrew's package management capabilities. Alternatively, if you have Python installed on your Mac, you can run pip install Azure-CLI. Again, once the installation is complete, verify it by running AZ space -- version. Finally, installation on Linux is also very simple. For Debian or Ubuntu, run the following command in your terminal: curl space -sl space https://aka.ms/install Azure CLI deb pipe sudo bash. Don't forget to run the AZ space -version command to verify the installation. With Azure CLI installed on your preferred operating system, you now have the power to automate, optimize, and enhance your workflow like never before. Think of all the tasks you can now simplify and execute faster. As a cloud support professional, using Azure CLI will make you more efficient and effective in managing your cloud resources. Remember, every automated task, every streamlined deployment, and every efficient resource management process you implement with Azure CLI makes your work more productive and less error-prone. With Azure CLI, you can transform the way you manage your cloud environment, making you a more effective cloud support professional. Imagine one day you're about to deploy a critical update to your company's cloud infrastructure, all from a single command line. You're using Azure CLI, a powerful tool that puts the control of Azure resources at your fingertips. But before you hit enter, a thought crosses your mind. How does Azure know it's really you issuing these commands? And how can you be sure your access is secure? This is where the robust identity and authentication mechanisms built into Azure CLI come into play. These mechanisms allow you to swiftly implement robust identity and authentication measures to safeguard your company's vital resources. In this video, you'll unpack the identity and authentication mechanisms in Azure CLI by exploring how they enhance security and streamline user management. In Azure CLI, identity refers to any user, service, or application interacting with Azure resources. It forms the foundation of access control and security within the Azure ecosystem. Azure CLI supports various identity types, including user identity, which represents an individual with an Entra ID. Service principal, which is an identity for an application or service that needs to access resources. And managed identity, which is a service identity that Azure automatically manages. Azure CLI offers multiple authentication methods to cater to different scenarios and security requirements. Firstly, interactive browser-based authentication redirects users to a web browser to complete the login process, supporting multi-factor authentication, or MFA, for enhanced security. This method is ideal for interactive sessions and personal use. In cases where browser access is limited, device code flow provides a code you enter on a separate device to authenticate. Next, service principal authentication uses a combination of tenant ID, client ID, and client secret or certificate. A client secret and a client certificate are both mechanisms used to authenticate and authorize a client application when it requests access to a protected resource, such as an API or web service. Service principal authentication is suitable for automated scripts, continuous integration and continuous deployment, or CI/CD pipelines, and headless applications. CI/CD is a set of practices that enable developers to automate the process of integrating code changes, testing them, and deploying updates to production environments. In a CI/CD pipeline, automated scripts build and test code with every commit, automatically deploying it to a staging environment once tests pass. Headless applications manage this entire process, ensuring efficient and error-free software deployment. Lastly, managed identity eliminates the need for credential management in code as Azure automatically handles token generation and rotation. The Azure CLI login command can initiate an interactive login process, cache credentials for subsequent commands, and support the specification of a tenant ID for multi-tenant scenarios. You'll explore an example of this later. Now, let's explore how to configure authentication in Azure CLI. To set up an authentication in Azure CLI, first install it on your system, and then open a PowerShell or command prompt. Next, run the AZ login command to initiate the authentication process and follow the prompts to complete it. Then, select your personal or work email address and log in with the proper credentials. Once you log in, Azure CLI will ask you to select a subscription. You can type the subscription number, for example, 1, 2, or 3, or press Enter to proceed with the selected subscription. After selecting the subscription, the system will confirm that you have successfully logged in and selected the subscription. You can also sign in directly on the command line using the AZ login command by including your username and password with the user and password flags. However, this is bad practice, as your password will be recorded in the command history, which anyone can access. You should only use this method to learn Azure CLI commands. In the production environment, it's more secure to log in with a service principal or managed identity. Two commands can help you avoid having your password recorded. In the command prompt, the read bash command will do the job. In PowerShell, you should use the get-credential command. It's important to note that signing in with credentials on the command line doesn't work with Microsoft accounts or accounts that have two-factor authentication enabled. You will receive an interactive authentication is needed message if you try to do so. Finally, let's discuss a few of the common authentication issues you may encounter when using Azure CLI. If your login isn't working, a simple solution is to log out using the AZ logout command and then log in again. This often resolves any temporary glitches. Another frequent problem is being repeatedly asked to log in, which usually means your session has expired or was not properly established. To resolve this, try logging in again by using the AZ login command. If the problem persists, ensure that your previous session is fully logged out by running AZ logout, then attempt to log in once more. This often resolves the issue by clearing any temporary authentication problems. Next, if you can't access a specific resource, it's likely a permissions problem. In this scenario, it's best to contact your Azure administrator, who can verify and adjust your access rights if necessary. Lastly, if your token has expired, you can refresh the expired token using the AZ account get access token command. These simple solutions can help you quickly address common authentication problems and ensure smooth usage of Azure CLI. In conclusion, identity and authentication in Azure CLI form the cornerstone of secure cloud resource management. By understanding and implementing robust authentication mechanisms, you can ensure that only authorized users and applications can access and manage Azure resources. You are a cloud support professional at a mid-sized tech firm. On Monday morning, you're given a critical task: set up a scalable and secure infrastructure for a new application using Azure. During a team meeting, your manager emphasizes the need to use the Azure Command Line Interface, or CLI, to speed up and automate the setup process. Your task is to efficiently create and configure the necessary Azure resources using Azure CLI while ensuring robust security practices. In this video, you'll explore essential Azure CLI commands, their structure and functionalities to manage and optimize Azure resources efficiently. The Azure CLI is a powerful tool for managing Azure resources. It offers commands to automate tasks, scale operations, and maintain control over your cloud infrastructure. For beginners, learning Azure CLI commands is crucial to streamline cloud management, increase productivity, and save time. Before exploring Azure CLI commands in detail, it's important to understand their basic structure. Each command in the Azure CLI follows a consistent structure, making it easy to learn and use. Let's break it down. Firstly, AZ is the base command that any Azure CLI command starts with. Secondly, command group specifies the category or type of resource you are managing, like VM for virtual machines or storage for storage accounts. Thirdly, command is the action you want to perform, such as create, list, or delete. Next, arguments provide the additional piece of information required for the command, for example, the name of a resource. Finally, options are used to modify the command's behavior, for instance, specifying output formats or filters. Understanding each part of the command structure helps you effectively construct and execute Azure CLI commands to manage your resources. Let's explore an example of using a command to create a Debian-based virtual machine. Debian is an open-source Linux-based operating system. In the command, VM is the command group, create is the command, and the rest are arguments and options that specify details about the virtual machine. Azure CLI offers a range of command groups and features to manage and configure Azure resources, which include resource management to manage resource groups, deployments, and templates, virtual machines to create, configure, and manage virtual machines, storage to manage storage accounts, containers, and blobs, and networking to configure virtual networks, subnets, and network security groups. These command groups provide a structured way to perform tasks and efficiently manage resources. Furthermore, getting help with Azure CLI commands is easy. Simply add --help at the end of any command to access detailed information, including a description of what the command does, how to use the command, including the required arguments, details about each argument and the available options, and practical examples of how the command is used. For example, AZ-VM create --help will display help for creating a virtual machine. You can also use the --help -output option to display help information in a specific output format, such as JSON or YAML. Additionally, the --help -query option displays help for querying command output. Next, let's discuss a few Azure CLI commands to help you create and manage resources and customize outputs. Commands you can use to create resources include AZ-group create to create a resource group, AZ-VM create to create a virtual machine, AZ-storage account create to create a storage account, and AZ-network VNet create to create a virtual network. Commands to manage and view your resources include AZ resource list to list all resources in a subscription, AZ account show to show account information and subscription details, and AZ network VNet list to list all virtual networks. You also have a few options available to customize the output of your commands. For example, use --query to filter and format the output, and --output to specify the output formats like table, JSON, or TSV. These are just a few examples of the many commands Azure CLI offers to manage and configure your Azure resources. Another great feature of Azure CLI is its interactive mode, which provides automatic help and suggestions as you type commands. In interactive mode, you can easily navigate through commands and subcommands while receiving prompts and hints to help you complete tasks. This mode is especially useful for beginners or anyone looking to explore Azure CLI commands and features. With interactive mode, you can browse through commands and subcommands, get real-time help and hints, easily select and execute commands, and learn about new features and capabilities. To enter interactive mode, use the AZ interactive command. And to exit interactive mode, simply type exit or press Ctrl+D on your keyboard. It's important to note that once you activate interactive mode, it may take a few minutes to load. Finally, Azure CLI provides scripting capabilities that integrate seamlessly with languages like Bash and PowerShell. These capabilities enable you to automate repetitive tasks and manage complex workflows. This feature is particularly beneficial for DevOps engineers and cloud specialists. Throughout this video, you explored essential Azure CLI commands and features that are key to efficient cloud management. Mastering these commands will streamline your workflows, help you automate tasks, and optimize the use of your Azure resources. By leveraging Azure CLI to automate, customize, and manage resources efficiently, you can build and maintain a scalable and reliable cloud infrastructure. Imagine transforming complex, time-consuming Azure management tasks into streamlined, automated processes, all while taking control of your entire cloud infrastructure with just a few lines of code. Sounds amazing, right? Whether you're a seasoned DevOps engineer or new to cloud management, mastering Bash with Azure CLI won't just streamline your tasks, it will change the way you work, dramatically boosting your productivity. In this video, you'll discover how to use Bash commands with Azure CLI to automate resource deployment, configure your environment, and efficiently manage your cloud infrastructure. But first, let's start by defining what Bash and Bash scripts are. Bash, short for Born Again Shell, is a command line interface and scripting language commonly used in Unix-like operating systems. Bash enables you to interact directly with the operating system through text commands. On the other hand, Bash scripts are text files that contain a series of Bash commands. These scripts enable you to automate tasks, create custom commands, and manage system operations efficiently. By writing Bash scripts, you can run multiple commands in order, use variables, and add logic to create powerful automation tools. To start using Bash, you'll need a few key components. A system that supports Bash. This can be a Unix-like operating system like Linux or Mac OS, or Windows with Windows Subsystem for Linux or WSL installed. Azure CLI must be installed on your system, and finally, an active Azure subscription to interact with Azure services. Once you have everything ready, you can use Bash with Azure CLI in one of two primary ways. First, through Azure Cloud Shell. This is a browser-based shell environment provided by Microsoft Azure. Azure Cloud Shell comes pre-installed with Azure CLI and other useful tools, so you can use Bash with Azure CLI without any local setup. Second, you can use Bash with Azure CLI on your local Bash environment. This includes Unix-like systems or Windows with WSL. In this case, you'll first install Azure CLI locally. After that, you can create and run Bash scripts that incorporate Azure CLI commands. Next, let's explore how to activate WSL to access the power of Bash on your Windows machine. Windows WSL is a feature of Windows 10 and Windows 11 that allows you to run a Linux environment directly on Windows without the need for a virtual machine. To activate WSL, open PowerShell or command prompt and run the WSL installation command. This will install a version of Ubuntu, a popular open source Linux operating system, for WSL on your machine. Next, restart your computer, after which Ubuntu will start to install. If it doesn't install automatically, run the WSL installation command again. Then, set up your Ubuntu Linux username and password. Once complete, search for Ubuntu in the Windows search bar and select Open to run it in PowerShell. You can now run Bash commands and Bash scripts within the Ubuntu terminal. The final step is to install Azure CLI within the Linux environment. Once installed, you can start using Bash with Azure CLI on your Windows machine to manage your Azure resources. With your system ready, a few Bash commands that you'll often use in Azure CLI include ls to list directory contents, cd to change directories, make dir to create a new directory, and rm to remove files or directories. A few more commands include cp to copy files or directories, mv to move or rename files or directories, echo to display a line of text, and touch to create a file in the current directory. These basic commands will help you navigate and manage your files and directories efficiently. When running your Bash commands or scripts, you can make use of variables, arrays, and loops to create dynamic, powerful automation scripts tailored to your needs. Variables in Bash act as containers for data, enabling you to store and reuse information throughout your scripts. For example, you might store the name of a resource group in a variable to use it multiple times without having to retype it. It's good practice to use identifiable variable names to improve code readability and maintenance. Arrays allow you to store multiple values in a single variable. For example, the VM sizes array stores 3 different VM sizes, and the echo command displays the array elements all at once. You can retrieve a particular value from the array by referencing its position or index in the array. For instance, in an array of VM sizes bracket 0 would return the first VM size in the array. Loops, such as the for loop, are essential for executing repetitive tasks efficiently. Here is an example of using a for loop to iterate through each element in the VM sizes array. The code then displays each VM size stored in the array. To bring it all together, here's an example script that combines variables, arrays, and loops to deploy multiple VMs. This script shows how to automate the creation of virtual machines using different sizes. The script creates variables for the resource group and location, defines an array of VM sizes, creates a resource group, uses a loop to create multiple VMs with varying sizes, and generates a list of all newly created VMs. Lastly, when you develop Bash scripts, you can use any text editor available in your Linux environment. Editors like Nano, Vim, and even Visual Studio Code are popular choices. Using Bash with Azure CLI provides a powerful and flexible way to manage Azure resources. By combining Bash's scripting capabilities with Azure CLI, you can streamline your operations, automate repetitive tasks, and maintain consistency across your cloud environment. Have you ever been faced with lots of data and needed to find exactly what you need fast? As a cloud support professional, understanding how to query command output in Azure CLI can make your work much more efficient. The Azure Command Line Interface, or CLI, is a powerful tool for managing resources. But the real magic happens when you start using it to ask specific questions and get exactly the answers you need. In this video, you'll learn how to retrieve specific data to optimize operations and make the most of Azure using simple yet powerful querying techniques. Let's start by defining what querying means in the context of command line interfaces and data manipulation. Querying is almost like asking a search engine a precise question to get a specific answer. It's the process of requesting and retrieving specific data from a larger set of information, making it easier to focus on what matters most, thereby optimizing operations. With Azure CLI, you can filter, sort, and format the data returned by your commands so you can focus only on the information that's important to you, ultimately saving time and effort. Let's break down a few key concepts you'll use when querying. Filtering is the first step, where you select a subset of data based on specific criteria. For example, you might focus on virtual machines that are currently running. After filtering, you might want to dig deeper into specific details. Projection allows you to focus on specific attributes or properties of the data, such as the name and location, rather than retrieving all the details about a resource. Next, transformation allows you to modify the structure or format of your data. For instance, you could group resources by type or change the output format from JSON to a table, making it easier to analyze the information. Finally, sorting helps you organize your results based on one or more attributes. For example, you could arrange resources by name alphabetically, providing a clear and ordered view of your data. In Azure CLI, a query typically starts with a command, such as AZ-VM-list, followed by the query parameter, and then the query expression enclosed in square brackets and quotation marks. The query expression in this command filters the results to display only the names of all virtual machines. Query expressions can range from simple property selections, like retrieving a resource's name, to complex filtering and transformation operations, such as filtering virtual machines by status and then grouping them by region. Azure CLI uses JamesPath, a powerful query language designed specifically for JSON-based systems. While it might seem complex at first, JamesPath simplifies even the most advanced queries, making it a valuable tool with practice. Next, let's discover how to refine your queries to get more targeted results, making it easier to find the exact information you need. By adding the expression power state is equal to VM running to the AZ-VM-list command, the query instructs Azure to return only the names of VMs that are currently running. Now, let's say you need more details, like the size of each VM, along with its name. You can modify the query to include multiple properties. For instance, this query returns a list of lists, with each inner list containing the name and size of a running VM. This way, you gain a more complete picture without being overwhelmed by too much data. You can also customize the output format using the output, or -O for short, parameter to make the data easier to read. For example, by adding -O table to the command, the results are displayed in a structured table format, making them easier to analyze. Now that you've learned how to refine your queries and adjust the output, let's explore how you can apply these techniques to real-world tasks. First, you can use a query to create inventories of your Azure resources. For instance, this command returns a list of all your VMs, along with their resource groups and locations, neatly organized in a table. Another practical use of querying is optimizing costs. For example, this query lists all unattached public IP addresses, which might be costing you money unnecessarily. Querying can also assist in monitoring the performance of your resources. By using the AZ-VM-list usage command, you can check the overall resource usage and limits for virtual machines in a specific region. This provides a quick overview of how much of your available resources, like CPU cores, are being used and whether any are close to their limits. Next, you can use queries to perform security audits. For example, by listing all network security groups with open SSH ports using the AZ network NSG list command, you can quickly identify potential security risks. Finally, querying is great for custom reporting. You can create custom reports by combining different Azure CLI commands with specific queries. For example, the AZ web app list command generates a report of all your web apps and their associated app service plans. This approach is particularly useful for capacity planning or cost analysis, as it delivers the exact information you need, organized in a way that's easy to understand and act on. Mastering Azure CLI querying is a powerful skill for cloud management. It enables you to extract exactly the data you need, streamline your operations, and make informed decisions quickly. Imagine you're new to Azure CLI, tasked with navigating its vast array of commands. The syntax might seem complex, and finding the right command might feel overwhelming. What if you could simplify this learning process? Azure CLI Interactive Mode, or AZ Interactive, offers a solution by simplifying command discovery, reducing errors, and helping you learn faster. With features like auto-completion, drop-down suggestions, and built-in examples, Azure CLI Interactive Mode makes learning and using commands more intuitive. In this video, you'll explore how to use Azure Interactive Mode to enhance your command line experience. Before you begin, make sure you have an active Azure subscription. Next, you have two flexible options for using the Azure CLI. Firstly, Azure Cloud Shell. This is an easy-to-use browser-based option that doesn't require any setup. Secondly, local installation. This gives you more control and flexibility. You can install the Azure CLI on either command line or PowerShell 7, depending on your preference. To start Azure CLI in interactive mode, simply run the AZ interactive command. This puts you in an interactive shell with auto-completion, command descriptions, and examples to guide you. Customize your interactive mode experience with the following key controls. Turn descriptions and examples on or off using the F1 key. Additionally, if you want to control whether parameter defaults are shown, just press F2 to turn it on or off. Finally, for more control, press F3 to show or hide key gestures, giving you a fully customizable interactive experience. Interactive mode provides a simpler way to run a group of related commands in Azure. Instead of typing out the full command every time, you can set a scope that focuses on a specific group of commands, putting you in control and saving you time. Let's explore how setting a scope works in practice. Suppose you're working with virtual machines or VMs in Azure. Normally, you might run commands that require you to type VM each and every time. But there's a way to overcome this repetition. You can instead adjust your scope to the VM group level. Simply type AZ $% VM. All your commands are now automatically in the VM group, saving you time and effort. What's more, you can focus on smaller groups within the VM group. For example, if you're dealing with VM images, you can type $% VM image to change the scope to VM image. However, since you're already in the VM scope, you'll just type $% image. Ready to switch scopes? It's as easy as typing $% ... to return to your previous scope, or just $% to return to the root scope. In interactive mode, you can use a powerful tool called a James Path query to search through the results of the last command you ran. This allows you to precisely filter and manage your data. To do this, you use double question marks followed by your query. For example, if you create a resource group and want to find its ID, you would run the following commands. You can also use the result of one command as part of the following command. For instance, if you listed all resource groups and then want to find something specific within them, you can use JamesPath to filter through the results from the list you just generated. This command lists all the resources of type virtual machine on the first group whose location is West Europe. Whether you're running Bash or PowerShell commands, interactive mode has you covered. For Bash scripts, use the hash followed by the command syntax. For PowerShell scripts, use standard PowerShell syntax. Another useful feature is the ability to quickly access examples of commands you've used, so you can easily reference or replicate them as needed. To do this, scroll through examples using Ctrl+N for the next page and Ctrl+Y for the previous page. You can also view a specific example by using the ## syntax. For instance, if you want to create a web app using a predefined configuration, you might type AZ web app create :2. The second example for creating a web app, in this case using the web app create -g command, is then displayed. When using interactive mode within Azure CLI, upgrade to the latest version to access AI-driven enhancements. These features take your Azure CLI experience to the next level, helping you work smarter. You upgrade to the latest version by running the AZ extension add command. With the AI-driven command suggestions, simply run a command, then press the space bar or move to the next step. The AI automatically generates a list of recommended commands to help you complete your task more efficiently. For AI-powered scenario recommendations, make sure you've run a command first. After it runs successfully, press the spacebar. The AI will then suggest a variety of related command sets based on your current context, and you'll notice that whichever set you select, a : number is added after the space. To search for specific commands or scenarios, type a / followed by a keyword, like resource. This AI-enhanced search quickly directs you to the commands and scenarios you need. Finally, if you prefer a more manual approach, you can easily disable AI suggestions in Azure CLI interactive mode using the azconfig set command. Azure CLI interactive mode transforms the way you work with Azure, making it easier to learn, execute, and master commands. Whether you're navigating complex command structures or simply need to reduce errors, this tool helps you operate with greater efficiency and confidence. The Azure Command Line Interface, or CLI, is your gateway to efficient Azure management. Whether you're deploying applications, configuring networks, or automating tasks, the Azure CLI simplifies it all. But to truly harness its power, you need to understand some key strategies. In this video, you'll discover essential tips and best practices that will help you maximize productivity, security, and efficiency with the Azure CLI. The first step to mastering the Azure CLI is to set up your environment properly. Here you have two main options. Use Azure's Cloud Shell, which is perfect for quick tasks as it comes pre-installed with all the tools you need, requires no setup, and connects directly to your Azure account. You can also install the Azure CLI on your local machine, offering more control and optimization. In this case, it's important to keep the CLI updated to ensure you have the latest features bug fixes, and security patches. Furthermore, you can configure default settings for your subscription, region, and resource groups. For example, use commands like AZ-configure -- defaults to set defaults, which will help you prevent errors and save time. Now that your environment is set up, it's crucial to efficiently navigate and manage your resources, starting with the right commands. Use AZ Resource List to view your resources and AZ Resource Show to get detailed information on specific ones. These commands are key to quick and effective resource management. A few best practices for managing resource groups include: organize your resources into groups based on their life cycle and purpose. Use easily identifiable naming conventions. And regularly review and clean up unused resources using Azure CLI commands like AZ Resource List and AZ Resource Delete. With your resources organized, it's time to focus on scripting and automation, the heart of efficient Azure CLI use. For effective scripting and automation, write scripts for frequent tasks and keep them version controlled. Integrate the CLI with your DevOps workflows and choose the right output formats and query parameters to streamline processes. Automation is powerful, but security is critical. Let's explore some security and access management tips to keep your environment safe. Use managed identities or service principals for secure access to Azure resources, avoiding personal credentials in scripts. And implement role-based access control, or RBAC, to ensure users and applications have only the minimum necessary permissions. While maintaining security, it's equally important to be prepared for troubleshooting. Let's discuss a few key strategies for diagnosing and resolving issues with the Azure CLI. To boost your troubleshooting skills with the Azure CLI, use the -- verbose and -- debug flags with commands for detailed output when issues arise. You can also get support by referring to the Azure CLI documentation and connecting with the Azure community on various platforms. Next, optimize performance by using the no-wait parameter to run multiple tasks simultaneously, especially when creating or deleting resources in bulk. This approach saves time and improves efficiency. What's more, you can take advantage of Azure CLI's advanced features and extensions to enhance your workflow and efficiency. Azure CLI extensions are add-ons that provide additional functionality to the CLI. You can easily install them using the AZ extension add command. For instance, the interactive extension offers an interactive mode with command suggestions, while the AKS preview extension adds extra features for managing Azure Kubernetes Service, or AKS. Furthermore, simplify your workflow by creating custom commands or aliases for frequently used commands or complex command chains. To further enhance the reliability of your scripts, consider implementing idempotency. Let's discover how this concept can make your automation more robust. Idempotency is a key concept in scripting that ensures a command or operation can be executed multiple times without changing the outcome beyond the initial application. This means that running the same command repeatedly will not alter the state of the system in unexpected ways. To implement idempotency, you can use flags like -- if dash exists to make sure your scripts can be run multiple times without unintended side effects. This practice ensures script safety in scenarios where execution might be interrupted or require repetition, contributing to more robust automation processes. Lastly, Azure CLI offers extensive built-in help and examples for every command, making it easier to master its full potential. Use the H or help flag to access detailed information about command usage and options. For instance, AZVM create-h offers comprehensive guidance on creating virtual machines, including optional parameters. This feature is invaluable for making the most of each command. By using these tips and leveraging the full capabilities of Azure CLI, you'll find that managing Azure resources becomes not only more efficient, but also more intuitive. The Azure CLI is more than just a tool. It's your partner in managing Azure resources effectively. With the right strategies, you can streamline workflows, boost security, and get the most out of your cloud operations. Suppose you're tasked with managing a complex Azure environment with multiple subscriptions, vast amounts of data, and intricate configurations. Navigating this landscape efficiently requires more than just basic Azure Command Line Interface, or CLI, commands. It demands mastery of advanced techniques that can save you time, reduce errors, and enhance your productivity. In this video, you'll explore 3 critical areas: advanced Azure CLI techniques, advanced James Path techniques, and Azure CLI output formats. Let's begin with advanced Azure CLI techniques, where you'll learn how to execute powerful commands that can transform how you manage Azure resources. Query mastery allows you to extract and manipulate Azure resource data efficiently, saving you time and reducing errors in data analysis. For example, to list all running virtual machines or VMs, you can use a powerful query command that filters and displays only the data you need. Another example is finding the VM with the most memory in a resource group. This command identifies and displays the VM with the highest memory allocation, helping you manage resources more effectively. Next, ARM template integration is a practice that leverages Azure Resource Manager, or ARM templates, for consistent, repeatable deployments and easy export of existing resources. Deploying an ARM template allows you to automate complex setups with just a single command. Additionally, you can export an existing resource group to an ARM template. This technique is useful for documenting or replicating configurations across environments. Managing resources across multiple subscriptions can be challenging, but Azure CLI simplifies this with commands that let you list subscriptions and set the active ones quickly. For example, here's how you can list all subscriptions in a table format. You can also perform operations across all subscriptions by combining commands. Handling sensitive information securely is essential in any cloud environment. Azure CLI integrates with Azure Key Vault to protect secrets, ensuring they're stored and retrieved safely. For example, after storing a secret, you can retrieve and use it in other commands, such as when creating a VM. Using monitoring and logging, you can gain insights into your Azure resources, performance, and troubleshoot issues effectively with built-in capabilities. For instance, retrieving metrics for a VM can help you identify and troubleshoot performance bottlenecks, while downloading logs from Azure Storage can assist in troubleshooting issues. Now, let's explore advanced James Path techniques for extracting and manipulating data with precision and efficiency. Complex filtering lets you create advanced filters to precisely select the data you need from Azure CLI outputs. For example, this command lists all running VMs in the East US with more than 2 data disks. It targets specific data within large datasets. Nested data access is another powerful technique that enables you to navigate complex data structures and extract specific information from nested Azure resource properties. This approach is crucial when working with resources that have multiple property layers, enabling you to pinpoint and retrieve deeply embedded data. For example, here's how to extract operating system or OS disk names and sizes for all VMs. Array slicing is a method for efficiently working with large data sets by selecting specific portions of arrays in your query results. This technique is especially useful when you need to analyze or display a subset of a larger collection, such as the first few items or a specific range of elements. For instance, you can quickly get the names of the first 3 VMs in your subscription. Custom sorting lets you order your query results by any property, enabling more meaningful data presentation. This advanced technique allows you to organize your data according to your specific needs, whether by name, date, size, or any other attribute. For example, you can sort all VMs by the size of their OS disk. Flattening and restructuring can transform complex Azure resource data into more manageable formats for easier analysis and reporting. This is particularly useful when working with nested or hierarchical data structures. Flattening simplifies nested Azure resource data into a flat, linear structure, while restructuring reorganizes the data into a different format or hierarchy, making it easier to analyze and report on specific attributes. Flatten VM data and list all disk names with this command. Finally, understanding Azure CLI's output formats is crucial for presenting data effectively. Azure CLI offers multiple output formats, allowing you to choose the one that best suits your needs and enhances your ability to interpret and work with command results. Firstly, JavaScript Object Notation, or JSON, is the default output format for Azure CLI. It's ideal for programmatic processing and provides a hierarchical view of the data. You can display VMs in JSON format with this command. The table format presents data in a human-readable structure, perfect for quick overviews and interactive work. Use this command to present VMs in a table format, making the data more readable. Tab-separated values, or TSV format, is useful when you need to import data into spreadsheet applications or process it further with text manipulation tools. This format is excellent when you need to manipulate the data outside of Azure CLI. Retrieve VM names and sizes in TSV format using this command. YAML-ain't markup language, or YAML, provides a more human-readable format than JSON, while still preserving the data structure. It's particularly useful when working with configuration files or documentation. Here's how to list VM names and their OS types in YAML format. You can also combine JamesPath queries with different output formats for highly customized results. For example, here's how to create a custom table of VA names, sizes, and OS types. By mastering these advanced Azure CLI techniques, JamesPath queries, and output formats, you've gained the tools to manage your Azure resources with precision and effectiveness. These skills will allow you to extract, manipulate, and present data in ways that perfectly align with your needs, driving better outcomes in your cloud management tasks. Suppose you are a cloud administrator managing user access across multiple Azure projects. As your organization grows, manually handling accounts and permissions becomes challenging. Azure CLI integrated with Entra ID, formerly Azure Active Directory, offers a powerful solution. It provides a command line interface to efficiently manage identities, control access, and implement security measures across your Azure environment. In this video, you'll learn how Entra ID seamlessly integrates with Azure CLI to enhance cloud resource management. You'll discover the key components, benefits, and practical applications in Azure environments. Let's begin by exploring a crucial concept. What is Entra ID? You might have known it as Azure Active Directory, but now it's evolved into something even more powerful. It's Microsoft's cloud-based identity and access management service. It's the key system for managing authentication and authorization across Azure resources and other Microsoft services. You can think of it as the gatekeeper to all things Azure and Microsoft. But what makes Entra ID so essential? It offers a wide range of powerful features, including comprehensive user identity management, granular access control to resources, multi-factor authentication, or MFA, and single sign-on, or SSO, capabilities. Simply put, Entra ID centralizes access control, safeguarding sensitive data and systems across Azure. To really understand Entra ID and how it connects with Azure CLI, let's define a few key terms. A tenant is a dedicated Entra ID instance that represents a single organization and its associated resources. A service principal is an identity created for applications, hosted services, and automated tools to access Azure resources without using personal credentials. It's like a username and password for an app, allowing it to perform tasks with specific permissions you assign, such as accessing a storage account or running scripts. Service principals are particularly useful for non-interactive sign-ins, such as automated scripts, CI/CD pipelines, or background services. Service principals can be assigned specific roles and permissions, providing precise control over what resources the application or service can access and the actions it can perform. Next, role-based access control, or RBAC, is a system that provides fine-grained access management for Azure resources. RBAC enables administrators to grant users, groups, or service principals only the permissions necessary to perform their tasks, following the principle of least privilege. RBAC supports the creation of custom roles and the assignment of built-in roles at various scopes, such as management groups, subscriptions, resource groups, or individual resources. An App ID is a unique alphanumerical identifier for applications registered in Entra ID. Lastly, a user principal name, or UPN, is a user identifier in the format of an email address used for authentication in Entra ID. These key terms form the foundation of how Entra ID manages access and identities in Azure. Next, let's discuss the benefits of using Entra ID with Azure CLI. First, enhanced security. By combining Entra ID with Azure CLI, you create strong authentication and authorization, keeping your resources safe when accessed through the CLI. Next, centralized identity management, SIEM, allows you to efficiently manage all user identities and permissions from a single central location. MFA adds another layer of security for CLI access, reducing the chances of unauthorized use. Automation becomes smoother with automation support, allowing secure, automated processes without needing manual logins, perfect for scripts and workflows. Not only does Entra ID simplify automation, but it also gives you complete control over who can access your resources with fine-tuned permissions. With detailed access control, you can assign precise permissions using RBAC, ensuring users only get access to what they need. Entra ID also brings audit capabilities, so you can track who accessed what and when, helping with compliance and security monitoring. Finally, SSO allows users to access multiple Azure services with one login, making things more convenient. Overall, using Entra ID with Azure CLI enhances security, streamlines management, and adds layers of convenience. Now, let's explore a practical example of using Azure CLI with Entra ID by leveraging this powerful combination to streamline your workflow. Starting with authentication, securing your Azure CLI operations is the first crucial step. Entra ID provides a robust mechanism to verify user identities before granting access, ensuring all subsequent operations are secure. To sign in with your Entra ID credentials, simply run the AZ login command. Once authenticated, managing your tenants and subscriptions is the next logical step. Efficient tenant management helps ensure that resources are properly allocated across your organization. A tenant in Entra ID represents your organization's dedicated space in the Azure cloud. To sign into a specific tenant, use the AZ login with tenant command. You would sign in with a specific tenant when you need to interact with resources that are isolated within that tenant's environment. And to list and set subscriptions, use the AZ account list and the AZ account set commands. As your workflow evolves, automating tasks with service principals becomes essential. They enable applications and scripts to securely interact with Azure resources, eliminating the need for human intervention. To create a service principal, use the AZ add sp create for RBAC command. And to sign in with a service principal, use the AZ login with service principal command. You would sign in with a service principal when you need to automate tasks or run scripts that require non-interactive sign-ins. Finally, managing users is a critical part of wrapping up your Entra ID workflow. User management is a core function of Entra ID, allowing you to control who has access to your Azure resources. The Azure CLI provides commands to create, list, and manage users directly from the command line. To create a new user, run the AZ add user create command. To list all users, use the AZ add user list command. And to get details of a specific user, use the AZ add user show command. The integration of Entra ID with Azure CLI offers a powerful tool set for secure and efficient cloud resource management. By leveraging this combination, you can enhance your organization's security posture, streamline operations, and maintain granular control over your Azure environment. It's Monday morning, and you've been tasked with deploying a number of virtual machines. You've done it before, but it's always been a manual and time-consuming process. You start to wonder, isn't there a faster, more efficient way to handle these deployments? Fortunately, Azure PowerShell offers the solution. Azure PowerShell is a powerful scripting language and command line shell built to manage and automate tasks in Windows environments, helping you streamline your cloud operations. In this video, you'll discover how Azure PowerShell can not only automate tasks, but also why it's the preferred tool over the Azure portal for many organizations. You'll learn about the key benefits and how to get started with PowerShell on different operating systems. Note that the descriptions of the commandlets to follow are simplified, with only the commandlet names conveyed verbally, while the precise syntax needed for execution in PowerShell will be displayed on screen. This approach will also be used in other videos throughout this lesson. The Azure PowerShell module offers significant advantages for managing Azure resources, making it an indispensable tool for organizations aiming to streamline their cloud operations. Let's explore some key benefits. First is automation. With Azure PowerShell, you can automate repetitive tasks using PowerShell scripts, which not only minimizes errors, but also boosts efficiency. For example, Instead of manually deploying VMs, you can automate the entire process with a script. PowerShell's scripting capabilities make it easy to replicate complex tasks and share them with your team. This helps streamline workflows and fosters collaboration across different departments. Flexibility and scalability are the other key advantages. You can tailor workflows and scale resources as needed, making PowerShell ideal for large-scale deployments. With its speed and efficiency, Azure PowerShell helps reduce deployment times and increase productivity, letting you focus on high-priority tasks. PowerShell also brings consistency. By standardizing resource configurations and deployments, it reduces the likelihood of errors and improves reliability. This module also integrates seamlessly with services like Azure DevOps, Azure Monitor, and Azure Security Center, offering a unified management experience. Furthermore, PowerShell supports role-based access control, or RBAC, which ensures that users only have access to the resources they need, enhancing security and compliance. For added peace of mind, Azure PowerShell supports auditing and logging across services, so every action is tracked and recorded, providing transparency and accountability. Azure PowerShell runs on Windows, macOS, and Linux, offering versatility no matter what platform you're using. And if you ever need help, extensive documentation and community support make it easy to get up to speed, even if you're new to Azure. By using Azure PowerShell, you can unlock the full potential of Azure, streamlining resource management, improving efficiency, and ultimately reducing costs. A key concept to understand is that while Azure CLI uses commands, PowerShell refers to its commands as commandlets. You'll use commandlets to perform various tasks like automating system configurations, managing resources, and installing software. Now that you know the benefits, let's get PowerShell installed on your machine. Installing PowerShell on Windows is pretty straightforward and doesn't require much tech expertise. Let's walk through the process. First, locate PowerShell on your system. If you're using Windows 11, simply type PowerShell into the search bar. Next, make sure you have the necessary permissions. Right-click the PowerShell icon and select Run as Administrator. This ensures that you can install software without any permission issues. Then, install the latest version of Azure PowerShell, also known as the AZ module. In the PowerShell window, run this install-module commandlet. If PowerShell asks you to install the NuGet provider, just type Y and press Enter. You might also be asked to trust the PowerShell gallery. Again, type Y and press Enter. If you already have an older version of the AZ module installed, it's a good idea to update it. Simply run the update-module commandlet. Finally, run the get-module commandlet to confirm that Azure PowerShell has been installed successfully. If the name and version of the AZ module installed on your system are displayed, you're good to go. Everything is installed and ready. Now, let's move on to macOS and Linux systems. To install PowerShell on macOS, open your terminal and run the brew install commandlet. And to install it on Linux, Debian, or Ubuntu, run the sudo apt-get update and sudo apt-get install commandlets. Now that the PowerShell is installed, type PowerShell in your search bar to launch it. This will open up the PowerShell interface, where you'll install the Azure PowerShell module. With PowerShell running, execute the install-module commandlet to install the AZ module. Again, if you already have an older version of the AZ module installed, update it by running the update-module commandlet. Don't forget to run the get-module commandlet to verify the installation. With Azure PowerShell installed on your preferred operating system, you now have the power to automate, optimize, and enhance your workflow like never before. Lastly, if you need to remove PowerShell from your system, follow these steps. To uninstall the AZ module, run the uninstall-module commandlet. Once that's done, you'll want to double-check that it's been fully removed by running the get-module commandlet. If everything was uninstalled correctly, this commandlet won't return any results, and you're all set. With Azure PowerShell at your disposal, you now have the power to automate tasks, streamline operations, and manage Azure resources more efficiently than ever before. From automating repetitive workflows to ensuring consistent deployments, Azure PowerShell simplifies cloud management, allowing you to focus on the strategic aspects of your projects. Imagine you're an IT administrator responsible for protecting your company's cloud resources on Azure. Ensuring that only authorized users and applications can access these resources, especially through the command line, is critical. With Azure PowerShell, you have a powerful tool for managing your cloud infrastructure. But before running any commandlets, it's essential to ensure secure authentication and access control. In this video, you'll unpack the identity and authentication mechanisms in Azure PowerShell, learning how they enhance security while streamlining the management of your resources. Remember, the descriptions of the commandlets are simplified to only include commandlet names, but the precise syntax will be displayed on screen. Identity in Azure PowerShell represents any user, service, or application that interacts with Azure resources. It's the foundation of security and access control within the Azure ecosystem. Azure PowerShell supports various identity types, including user identity for individual users with an Entra ID, service principal for applications or services needing resource access, and managed identity, which Azure manages automatically for hosted applications. Azure PowerShell provides several authentication methods to suit different scenarios and security requirements. The first method is interactive browser-based authentication. This method directs users to a web browser for login, and it supports multi-factor authentication, or MFA, for enhanced security. When you run the connect-az account commandlet without any parameters, it initiates an interactive login process that redirects you to a web browser. From there, you can sign in with your Azure account credentials. If your account requires MFA, this process will handle that seamlessly, making it a secure option for personal use and interactive sessions. If you're working in a non-graphical environment, such as over SSH or on a system where browser access is restricted, the device code flow method is a great alternative. This method provides a code that you can enter on another device to authenticate, making it particularly helpful when you're working on a terminal-only environment, but still need to authenticate securely. To start this process, you'll run the connect-az account commandlet. Next, service principal authentication is the preferred method for automated tasks and scripts, CI/CD pipelines, and headless applications. It provides secure, non-interactive access by using a combination of tenant ID, client ID, and either a client secret or certificate, allowing fine-grained control over permissions and access scopes. To authenticate in automated workflows, run the connect-az account commandlet. Lastly, the managed identity method simplifies authentication by eliminating the need to store or manage credentials within your code, as Azure automatically handles token generation and rotation for you. This method is also one of the most secure options for Azure-hosted applications and services because it prevents credentials from being exposed in the code. To authenticate using a managed identity, run the connect-az account commandlet. Now, let's explore how to set up authentication in Azure PowerShell. If not already installed, the first step is to install Azure PowerShell on your system. Next, launch PowerShell with administrative privileges, and run the authentication commandlet to initiate the authentication process. Then, follow the prompts to log in with your Azure credentials. You also may need to select the subscription you want to work with. You can specify a particular subscription using the set-az context commandlet if you manage multiple subscriptions. After logging in, Azure PowerShell will cache your credentials for subsequent commands. You can also sign in with credentials on the command line using the AZ login commandlet with a username and password. However, this is not recommended, as your password will be recorded in the command history, which anyone can access. A safer alternative is to use the get-credential commandlet along with connect-az account. This method prompts you to enter your username and password in a secure pop-up window, helping to prevent your credentials from being exposed in the command line history. It's important to note that while get-credential provides a more secure way to enter your credentials temporarily, this method should only be used for learning or small-scale testing purposes. For production environments where security, automation, and scalability are critical, the best practice is to use more secure authentication methods, such as service principals or managed identities. Finally, let's discuss a few of the common authentication issues you may encounter when using Azure PowerShell. If your login isn't working, try logging out using the disconnect-az account commandlet, and then log back in with the connect-az account. This often resolves temporary glitches. Another frequent issue is repeatedly being asked to log in, which usually indicates your session has expired. In this case, simply log in again using the connect-az account commandlet. If you can't access a specific resource, it's likely a permissions problem. In this case, verify your permissions. You may need to contact your Azure administrator to adjust your access rights if necessary. Lastly, if your token has expired, you can refresh it using the get-az access token commandlet to avoid being logged out unexpectedly. These simple solutions can help you quickly address common authentication problems and ensure smooth usage of Azure PowerShell. In conclusion, whether you're managing users, automating tasks with service principal authentication, or securing hosted applications through managed identity, the methods you've learned in this video equip you with the tools to ensure secure authentication and access control. By leveraging Azure PowerShell's identity and authentication features, you can guarantee that only authorized users and applications can access and manage Azure resources, a critical step towards securing your cloud environment. By now, you're probably aware that Azure PowerShell is a powerful tool for automating tasks and managing resources within Azure environments. A key aspect of effective resource management and automation in Azure is mastering the fundamental PowerShell commands to perform complex tasks efficiently. In this video, you'll explore how to use Azure PowerShell to effectively manage resources within your environment, allowing you to automate tasks and improve efficiency. First things first, let's locate PowerShell on your system. If you're using Windows 11, simply type PowerShell into the search bar. You'll notice 4 different shortcuts for PowerShell available on 64-bit versions of Windows. These include Windows PowerShell, the default 64-bit console for running commands; Windows PowerShell ISE, the 64-bit integrated scripting environment for scripting and debugging; and Windows PowerShell x86 and Windows PowerShell ISE x86, the 32-bit versions of the console and ISE. These shortcuts allow you to choose between the 64-bit and 32-bit environments, depending on your needs. Before exploring specific PowerShell commands, it's essential to grasp their basic structure. In PowerShell, commands are called commandlets, and they follow a simple, predictable pattern that makes them easy to understand and use. Every commandlet is composed of a verb noun with optional parameters and arguments. Let's break it down. Firstly, the verb represents the action the commandlet performs, such as get, set, remove, or new. Secondly, the noun specifies the object the commandlet is working with, such as process, service, or item. Thirdly, parameters are optional elements that modify the behavior of the commandlet. For example, -name, -path, or -force can alter what the commandlet does. Lastly, arguments provide specific values for the parameters. For instance, -name notepad indicates the exact item you're targeting. By understanding this simple structure, you'll be able to construct and execute PowerShell commands more effectively, helping you manage and automate tasks with ease. To demonstrate a basic commandlet in action, let's use the getProcess commandlet to retrieve a list of all running processes on your system. This commandlet follows the basic structure, where the verb get retrieves data, and the noun process specify the type of retrieved object. Since there are no additional parameters or arguments, the commandlet will list all running processes on your system by default. PowerShell offers a range of commandlets to efficiently manage your system and automate tasks. Let's discuss the essential ones based on functionality. To retrieve system information, these commandlets give quick access to details like running processes, active services, and event log entries. Get-process retrieves a list of currently running processes on your system. Get-service displays the status of services, for instance, what's running or stopped. And get-event log retrieves entries from event logs, helping you track system and application events. Next, file system management is essential, and these commandlets help retrieve, modify, and remove files or folders efficiently. Get-item retrieves an item from a specific location, such as a file or folder. Set-item modifies the value or properties of an item, and remove-item deletes an item like a file or directory from a specified location. Lastly, for managing users and permissions, these commandlets simplify handling accounts and managing group memberships. Get-local user lists all the local user accounts on your system. New-local user creates a new local user account, and add-local group member adds a user to a local group so you can control their access and permissions. If you ever feel stuck or unsure about a commandlet in PowerShell, don't worry. There's a built-in help system ready to guide you. Use the get-help commandlet followed by the name of the commandlet you need help with. For example, get-help, get-process. Running this command will give you detailed information about how the get-process commandlet works, including the following. Syntax. This shows the correct format for using the commandlet. Description. A summary of what the commandlet does. Parameters. Detailed information on each available parameter. And examples. Practical examples that illustrate how the commandlet is used. A few other examples of get-help commandlets you can use are get-help get-service. This provides help for the get-service commandlet, which checks the status of system services. Get-help new-item displays help for creating new items, like files or folders. And get-help set-execution policy provides help configuring the script execution policy on your system. PowerShell also lets you update the help files or open detailed online documentation. Update-help downloads the latest help files to ensure your information is up to date. And get-help-online opens the online version of the help topic, which often includes even more detailed documentation. What's more, PowerShell offers an interactive experience, allowing you to discover commandlets in real time. Once you start a PowerShell session, you can experiment with commandlets, use tab completion to explore available commandlets and parameters, and use the get-command commandlet to list all available commandlets and functions. For example, to explore all commandlets that start with get, you can run get-command get-all. Finally, one of PowerShell's greatest strengths is its ability to automate tasks through scripting. You can write scripts to automate complex tasks, perform batch operations, and manage configurations across multiple systems. Here's an example of a simple PowerShell script that automates the backup of a directory. This script copies all items from the C drive data directory to the D drive backup directory, automating the backup process. In this video, you've learned how Azure PowerShell simplifies resource management, task automation, and operational workflows in your Azure environment through flexible and powerful commandlets. Whether it's managing resources, streamlining tasks, or automating complex workflows, Azure PowerShell enhances your control and efficiency, helping you optimize your infrastructure and security. Have you ever wondered how your devices seem to effortlessly share information across different apps and services? Whether it's syncing your contacts, connecting to cloud storage, or integrating with other tools, this communication happens seamlessly thanks to Application Programming Interfaces, or APIs. APIs work behind the scenes, acting like a coordinator that ensures different systems can communicate efficiently without needing to understand each other's inner workings. In this video, you'll explore the core concepts of APIs, their significance in software development, and how they can be leveraged using PowerShell for automation and integration tasks. Let's start by defining what an API is. An Application Programming Interface, or API, is a set of defined rules and protocols that allow different software applications to communicate and interact with each other. It acts as a contract between two software components, outlining how they will communicate. Think of an API as a waiter in a restaurant. The customer, who represents a software application, places an order, or API request, with the waiter, who is the API. The waiter then communicates this order to the kitchen, which is another software application. The kitchen prepares the food, which represents the data or service, and the waiter delivers it back to the customer. So in essence, APIs simplify the complexity of connecting different software systems by providing a standard way for them to communicate. They define the correct way for developers to request services from an operating system or other applications. APIs also specify the available endpoints and methods, the required data formats, and the conventions that need to be followed. APIs are essential because they allow different systems to interact and share functionality without needing to understand each other's inner workings. In the restaurant analogy, it's a bit like the waiter placing an order. He doesn't need to know how the chef prepares the meal, just how to relay the request and deliver the result. This separation makes systems more scalable, easier to maintain, and reusable across different applications. Let's discuss a few key ways APIs enable functionality. Firstly, APIs let applications share data. For example, a weather app doesn't generate its own weather data. It pulls this information from a weather service via an API. Secondly, APIs allow third-party services to be integrated into your application, such as payment processing through Stripe or PayPal, authentication via OAuth, or using Google Maps for location services. Lastly, APIs can automate processes between systems. For example, CI/CD pipelines use APIs to automate software testing, deployment, and monitoring. In short, APIs are the backbone of modern software ecosystems, helping diverse applications work together effortlessly. By now, you should be familiar with Azure PowerShell, a powerful scripting language and automation framework. Welcome to the gourmet restaurant of system integration and automation, where APIs meet PowerShell to deliver a seamless dining experience. PowerShell interacts with APIs to automate tasks, retrieve data, and manage resources across various platforms. One of PowerShell's key strengths is its ability to work with representational state transfer application programming interface, more commonly known as REST API, which are widely used for system integration and workflow automation. REST APIs use standard HTTP or HTTPS methods to communicate over the web and interact with services. For example, you might retrieve data from a weather service or submit a form to create a new user. Some of the most common HTTP methods include GET for retrieving data from a web service, POST for sending data to a web service, PUT for updating existing data on a web service, and DELETE for removing data from a web service. In PowerShell, you'll use commandlets like invoke-rest method and invoke-web request to send HTTP requests and handle API responses. These commandlets allow you to interact with any RESTful API, helping you automate complex tasks and integrate systems effortlessly. Now that you understand the importance of APIs and how they work with PowerShell, let's examine an example to bring it all together. Imagine you want to retrieve data from a public API using PowerShell. Here's a simple script that performs a GET request to fetch data from an API and processes the response. In this script, $API URL sets the web address of the API you're connecting to. Invoke-rest method sends a GET request to fetch the data from the API. The data that's returned by the API is then stored in the $response variable, and write-output displays that data. APIs are integral to modern software development, enabling seamless integration and automation across diverse systems. With PowerShell, you can harness the power of APIs to automate tasks, manage resources, and streamline your operations efficiently. Whether you're retrieving data, posting updates, or integrating complex workflows, PowerShell and APIs provide a robust framework to enhance your automation capabilities. You're part of a cloud operations team managing a large Azure environment. Until now, you've relied on traditional PowerShell commandlets for provisioning and configuring tasks. But as your environment grows more complex, you start encountering limitations, like restricted functionality, slower processes, or gaps in managing specific Azure services that make traditional commandlets feel less capable. That's when a colleague introduces you to invoke-AZ-rest method, a powerful commandlet that opens the door to more direct and flexible management of Azure resources. In this video, you'll learn how to leverage the invoke-AZ-rest method commandlet to perform various management tasks in Azure, enhancing your ability to automate and control your cloud environment. Let's begin by uncovering what the invoke-AZ-rest method commandlet can do for you and its basic syntax. This versatile commandlet in Azure PowerShell allows you to send HTTP requests directly to Azure's REST APIs. This means you can communicate with Azure services on a deeper level, enabling you to do tasks that other PowerShell commandlets may not, such as creating a new storage account with specific parameters. More examples like this will follow later. Here's how the basic syntax of the Invoke-AZ REST method commandlet is structured, and we'll break down the key parts. In this syntax, dash method specifies the type of HTTP method you'll use, such as get, put, patch, or delete, depending on what action you want to perform. Dash path defines the API endpoint you're targeting. Think of it as the exact address within Azure that you're communicating with. Dash payload is optional and needed for methods like post and put, where you're sending data. Typically, the payload contains JSON data, and Dash API version ensures you're using the correct version of the API to interact with the Azure resource provider. Previously, you learned about representational state transfer, or REST APIs, used for system integration and workflow automation. It's essential to familiarize yourself with these Invoke-AZ REST method parameters, as they form the foundation for crafting REST API calls to manage your Azure resources effectively. Before you use Invoke-AZ REST method, make sure your PowerShell session is connected to Azure. You can do this using the connect-AZ account commandlet, which links your session to your Azure account. Once authenticated, Azure PowerShell will have access to your subscriptions, and you'll be ready to manage your resources with Invoke-AZ REST method. Now, let's walk through a few real-world scenarios where Invoke-AZ REST method can help you automate and control your cloud environment. Suppose you need to retrieve details of a specific resource, such as a virtual machine or VM, within a particular resource group. You can use Invoke-AZ REST method to access the VM's current configuration and status. In this case, the method parameter is set to get to retrieve the data, while the path parameter specifies the API endpoint, including the resource group and VM name. The response is then parsed, converting the data from JSON format into a readable PowerShell object. This allows you to easily display and work with the virtual machine's configuration details. This approach is particularly useful if you want to retrieve the current configuration or status of any Azure resource. Another common task that you can automate using Invoke-AZ REST method is creating a new resource. Let's say you need to create a storage account with specific settings like location, SKU, and type. You can send a payload containing these details directly to Azure's API, and a new storage account will be provisioned. In this command, the method is set to put because you're creating a new resource. The payload parameter contains the JSON formatted body of the request, specifying the storage account's properties like location, stock keeping unit, or SKU, and kind. A storage account is created, and the response parsed, confirming that the creation was successful. This is a great example of how resources can be provisioned automatically through a script rather than manually. Next, when it comes to updating an existing resource, Invoke-AZ REST method can handle tasks such as modifying tags on a virtual machine. This script enables you to make targeted updates without altering the entire resource configuration. Here, the method is set to patch, which is specifically used for making partial updates, and the payload contains the modified tags. Once the operation is completed, the response shows the updated tags, confirming that the changes have been applied. Lastly, if you need to delete a resource, such as an unused storage account, the delete method allows you to remove the resource cleanly. This script performs the deletion through a straightforward API call. In this example, the method is set to delete to remove the specified resource. Once executed, the response confirms that the resource has been successfully deleted. Before wrapping up, let's cover some key best practices for using Invoke-AZ REST method. First, always ensure you're using the correct API version for the resource provider, as it can affect compatibility and available features. Next, implement solid error handling in your scripts to manage failed requests or unexpected responses effectively. Finally, avoid hard-coding sensitive information like API keys directly in your scripts. Use secure methods to manage credentials instead. The Invoke-AZ REST method commandlet is a powerful tool in Azure PowerShell, granting direct access to Azure's REST APIs for advanced resource management. Whether you're retrieving, creating, updating, or deleting resources, this commandlet provides precise control over your Azure environment. Mastering Invoke-AZ REST method can significantly enhance your automation capabilities, streamline operations, and help you manage your Azure resources more efficiently. Ever felt overwhelmed by the amount of data returned from your Azure PowerShell commands? Querying and filtering command output effectively is crucial when managing Azure resources, especially as environments grow more complex. In this video, you'll learn how to query and manipulate command output in Azure PowerShell to extract relevant information and filter results based on your needs. Let's start by covering the basics of command output in Azure PowerShell. When you run a command in Azure PowerShell, it typically returns objects that contain various properties and methods. These objects represent data such as virtual machines or VMs, resource groups, or storage accounts, each packed with valuable details. When working with VMs, for instance, the get-AZVM commandlet can return objects with properties like name, power state, and VM size, giving you detailed insights into each VM. However, the raw output can often be overwhelming or include more information than you need. To effectively manage and interpret this data, Azure PowerShell provides several commandlets and techniques for querying and formatting command output. This enables you to extract only the information you need, making it easier to analyze and take action. Let's explore some techniques you can use to query and format command output in Azure PowerShell. One of the most common tasks when working with command output is selecting specific properties from the returned objects. The select-object commandlet allows you to pick out only the fields you're interested in. Suppose you want to retrieve the names and statuses of all virtual machines in a specific resource group. In this command, get-AZVM retrieves VMs from a specified resource group, while select-object-property name power state filters the output to display only the name and power state properties. This technique is particularly useful when generating reports or when you're only interested in a subset of the available data. Often, you need to filter the output based on specific criteria. The where-object commandlet allows you to filter objects in the pipeline based on conditions you define. To illustrate this, let's say you want to list all virtual machines that are currently running. To further refine your results, you can use where-object $_.powerstate equals VM running to filter the output, returning only the VMs that are currently running. The where-object commandlet is powerful for filtering large datasets to only list items that meet specific criteria. In addition to filtering, you might want to sort your output based on specific properties, such as sorting a list of VMs by their names. The sort-object commandlet allows you to easily sort your data in the desired order. In this example, sort-object-property name sorts the list of virtual machines by their name property. You can also sort by multiple properties by specifying them in a comma-separated list, giving you further control over the presentation of your data. For instance, you can sort virtual machines first by their power state and then by name. While querying data is important, how you present that data is equally crucial. Azure PowerShell offers several commandlets for formatting output, including format-table and format-list. The format-table commandlet is ideal for displaying data in a tabular format, which is often the most readable when working with multiple objects. To enhance readability, format-table-property storage account name SKU.name in this command neatly displays storage account names and their stock keeping unit, or SKU, sizes in a neatly aligned table. The format-list commandlet is better suited for scenarios where you need to view detailed information about each object, especially when each object has many properties. This command outputs all properties of the virtual machine in a list format, making it easier to review comprehensive details. Another useful commandlet is group-object, which groups objects by a common property. This is particularly helpful when you need to find out how many objects share a specific characteristic. Running this command, the VMs are grouped by their power state, allowing you to examine how many are running, stopped, or in other states. Once you've queried and formatted your data, you might need to export it for reporting or further analysis. Azure PowerShell allows you to export data in various formats, such as CSV, JSON, or XML, using commandlets like export-CSV, convert to-JSON, and export-CLI XML. For example, you can export the list of running virtual machines to a CSV file. In this script, export-CSV with the path cdrive vms running.csv, and the no type information parameter saves the selected properties of the running VMs to a CSV file. Exporting data in the correct format is crucial for sharing information with stakeholders or for archival purposes. In conclusion, mastering the ability to query and format output in Azure PowerShell is crucial for effectively managing Azure resources, helping you streamline data analysis and make informed decisions. By using commandlets like select-object, where-object, sort-object, and formatting tools, you can work with clean, organized data, improving efficiency and enhancing automation in your Azure environment. Picture working with Azure PowerShell in a way that lets you test, adjust, and refine your commandlets in real time. No waiting, no full scripts, just immediate results at your fingertips. Welcome to interactive mode in Azure PowerShell, where each commandlet brings you closer to mastering Azure resources. In this video, you'll explore how interactive mode empowers you to work efficiently, troubleshoot on the spot, and make the most of your command line experience. By now, you're probably familiar with using interactive mode in other Microsoft tools, such as Azure Command Line Interface or CLI, which provides real-time suggestions and guidance to make commandlet execution intuitive and user-friendly. In PowerShell, interactive mode goes beyond guided commandlet input. It allows you to execute commandlets step by step, view immediate results, and fine-tune your scripting approach. This makes interactive mode ideal for exploring Azure PowerShell, testing commandlets, and detailed troubleshooting rather than just command discovery. Unlike writing a full script and executing it all at once, interactive mode lets you work step by step, making it easier to experiment and learn. To begin, launch Azure PowerShell by searching for Azure PowerShell in your Start menu or by using the pwsh commandlet from your terminal or command prompt. Once it's running, you're automatically in interactive mode, ready to execute commandlets step by step. One of the main benefits of interactive mode is the ability to explore available commandlets as you go. If you're unsure of what commandlets are available, simply use the get command commandlet to explore the options. This displays all the commandlets available in the AZ module, which includes commandlets for managing Azure resources. To narrow down the list, you can use wildcards by typing get-command space asterisk VM asterisk. This will list all commandlets related to virtual machines, helping you quickly find the specific commandlet you need. When working interactively, it's important to understand what a particular commandlet does and how to use it. The get-help commandlet is your go-to resource. It provides detailed information about the get-azvm commandlet, including its syntax, available parameters, and usage examples. For more detailed real-world examples, you can add the examples parameter. These examples show practical usage scenarios, helping you learn how to effectively apply the commandlet to your task. Interactive mode enables you to execute commandlets and instantly view the results. For example, to list all resource groups in your Azure subscription, run get-az resource group. The output displays details of each resource group, including the name, location, and provisioning state. From there, you can decide your next steps, like drilling down into a specific resource group or performing actions like creating or deleting resources. What's more, interactive mode is perfect for experimenting with different parameters and options without committing to a full script. Let's say you're working with virtual machines and want to observe how various configurations impact the results. You can start with a basic commandlet, such as get-azvm. Then refine your output by adding parameters, for instance, -resource group name with my resource group as the value. This approach allows you to build your commandlet incrementally, testing and adjusting as you go, making it ideal for learning and troubleshooting. Another feature to boost efficiency in Azure PowerShell is using aliases, which are shortcuts for commandlets. Instead of typing out the full get- command, you can use its alias, GCM, which reduces the amount of typing needed in interactive mode. You can find the alias for any commandlet by typing get-alias-definition followed by the specific commandlet. This will display the alias for the commandlet you selected. Learning and using aliases for frequently used commandlets can save time and make your interactive sessions more streamlined and efficient. In PowerShell, variables are used to store data that you can reuse throughout your session, and interactive mode makes working with these variables seamless and efficient. To illustrate this, the variable $VM is assigned the output of the get-azvm commandlet. You can then use this variable to access the virtual machine's properties in subsequent commandlets without rerunning get-azvm. This approach is particularly useful when working with complex or large data sets. The pipeline operator is a powerful feature in PowerShell that allows you to pass the output of one commandlet directly into another as input. In interactive mode, you can use the pipeline to chain multiple commandlets together, allowing you to accomplish more complex tasks. Take a scenario where you want to list all running VMs along with their names and resource groups. You can pipe get-azvm into where-object to filter running VMs, and then into select-object to display their names and resource group properties. Furthermore, interactive mode is useful for debugging and handling errors. If a commandlet fails, for example, because the virtual machine doesn't exist, you'll receive an error message that helps diagnose the issue. You can then correct the commandlet and try again, all within the same session. Lastly, tab completion is a helpful feature in PowerShell that allows you to quickly complete commandlet names, parameters, and file paths. This allows you to start typing a commandlet name and press tab. PowerShell will cycle through all commandlets that match, helping you quickly find and complete the commandlet you need. Interactive mode in Azure PowerShell transforms how you manage, troubleshoot, and explore Azure resources. With tools like get-command, get-help, tab completion, and the pipeline, you can work efficiently, adapt quickly, and gain deeper insights, all within the command line. No matter your level of experience, interactive mode offers a hands-on, step-by-step approach that enhances your command of Azure PowerShell. By now, you should have a solid understanding of how Azure PowerShell helps you manage and automate your Azure resources. However, to use it effectively, you need to apply key best practices consistently in your daily tasks. In this video, you'll discover 10 tips to boost productivity, enhance security, and streamline your cloud operations using Azure PowerShell. Ready? Let's get started. Remember, the descriptions of the commandlets are simplified to only include commandlet names, but the precise syntax will be displayed on screen. Before managing Azure resources with PowerShell, you first need to authenticate your session. To achieve this, the first commandlet to run is connect-az account. This commandlet prompts you to log in and establish a connection to your Azure subscriptions. Start each session with this commandlet to ensure you're authenticated and ready to manage your Azure environment. If you manage multiple subscriptions, use the -subscription parameter and specify the subscription name to target the correct one. This ensures your commandlets are executed in the correct context, preventing accidental changes in the wrong subscription. Azure PowerShell is organized into modules, each focused on specific areas like virtual machines, networking, or storage. To ensure you're working with the latest features and fixes, regularly update these modules by running the update-module commandlet and specifying the module name, for instance, AZ. As a best practice, you should focus on the modules relevant to your tasks. This helps you streamline your workflow. For example, if you're managing storage accounts, run the import-module commandlet to load the az.storage module. This reduces load times and memory usage, making your session more efficient. Aliases are shortcuts for frequently used commandlets, allowing you to execute them more quickly. Consider familiarizing yourself with command aliases to speed up your workflow. Here are a few common ones to get you started. Instead of typing get-command, you can use the alias GCM. Similarly, you can use GCI instead of get-child item and GPS instead of get-process. You can also create your own aliases to shorten longer commandlets. For instance, if you frequently use the get-AZ resource group commandlet, create an alias with the set-alias commandlet. Now, instead of typing the full commandlet, you can just type get rg and it will execute get-AZ resource group for you, saving time and reducing keystrokes for a more efficient workflow. Error handling is essential for writing robust PowerShell scripts. Using try, catch, and finally blocks enable you to manage errors gracefully. This ensures your scripts run smoothly, even when things go wrong. To illustrate this, let's say a virtual machine fails to start. The catch block logs the error, while the finally block executes cleanup actions, ensuring the script completes smoothly. This structure ensures that your script handles unexpected situations while completing necessary actions. The pipeline is one of the most powerful features in PowerShell, allowing you to pass the output of one commandlet directly into another. A good application is using the pipeline, represented by the pipe symbol, to chain or link commandlets together to process data more efficiently. Take a scenario where you want to find and stop all running VMs in a resource group. You can pipe get-azvm into where-object to filter running VMs, and then into stop-azvm to stop them. The pipeline allows you to perform complex operations in a single, concise, and efficient commandlet sequence. PowerShell's built-in help system is an invaluable resource. If you're ever unsure about a commandlet or need to check its parameters, use get-help to quickly access detailed information and examples. Including the full or examples parameters provides comprehensive details and practical examples. This will save you time and help you avoid mistakes by ensuring you're using commandlets correctly. When working with Azure PowerShell, it's essential to handle credentials and sensitive data securely. One way to do this is to avoid hard-coding passwords or secrets directly in your scripts. Instead, you can use the get-credential commandlet to prompt for credentials securely. Or use Azure Key Vault to securely store and retrieve sensitive information. This approach ensures that your scripts remain secure and follow best practices. If you find yourself repeating the same set of commandlets, consider creating a function. Functions encapsulate your logic, making your scripts cleaner and easier to maintain. For common tasks like creating resource groups or managing virtual machines, you can define reusable functions. Let's say you frequently start virtual machines. You can create a function called start-myvm. This function takes two parameters, the virtual machine name and the resource group name, and then runs the start-azvm commandlet to start the specified VM. Then, instead of typing the full commandlet each time, you can simply use the start-myvm function to start the VM, streamlining your workflow. Monitoring and logging are crucial for understanding the behavior of your scripts, especially in production environments. Logging helps you track the execution flow and catch any issues that arise. As a best practice, use write-output or create a custom write-log function to track key actions and catch errors along the way. This practice ensures you have a detailed record of your script's activity, helping with troubleshooting if something goes wrong. Azure PowerShell evolves quickly, with new commandlets and features added regularly. Staying current with these changes is essential for maintaining your scripts and utilizing the latest capabilities. Regularly review the official Azure PowerShell documentation for updates and new features. Additionally, join online communities, forums, or user groups to learn from others and share your own experiences. By applying these tips and best practices, you'll be well equipped to use Azure PowerShell effectively in your daily operations. From securely managing credentials to leveraging the pipeline, these strategies will optimize your workflow, enhance script reliability, and boost productivity in Azure Resource Management. In a crucial meeting with the executive team, new goals are set. Speed up Azure resource deployment, reduce manual management, improve system reliability, and ensure compliance with security standards. Your team is tasked with finding a solution that addresses these goals without adding complexity to your operations. Currently, you use Azure PowerShell to automate the creation, configuration, and management of your cloud resources. But to meet the company's objectives, it's time to move beyond basic scripting and explore advanced techniques. In this video, you'll discover how to use functions, modules, error handling, and automation to streamline Azure resource provisioning, transforming how your team meets its targets. Remember, the descriptions of the commandlets are simplified to only include commandlet names, but the precise syntax will be displayed on screen. Let's begin by answering the question, why is advanced scripting essential? Advanced PowerShell scripting helps you automate complex tasks, minimize manual work, and keep your Azure environment consistent. By creating reusable, modular, and robust scripts, you can efficiently scale your operations while minimizing errors during resource provisioning. This approach is especially critical in large-scale environments, where manual configurations often lead to inconsistencies, delays, and potential misconfigurations. To get the most out of advanced techniques, ensure your Azure PowerShell environment is properly configured. First, install the latest Azure PowerShell modules using the install-module commandlet. Make sure to run this command as an administrator. Next, connect to your Azure account using the connect-az account commandlet. Finally, use the set-az context commandlet to set your active subscription, ensuring you're working in the correct context. This setup ensures that all your commands and scripts are executed within the correct Azure subscription, preventing unintended changes in other environments. With your system now ready, let's explore some of the advanced scripting techniques you can use in PowerShell. One of the key principles of advanced scripting is modularity. In PowerShell, this means breaking your tasks into smaller, reusable functions instead of writing long, complex scripts. A function is a self-contained block of code designed to perform a specific task. Using functions makes your scripts easier to manage and debug, and allows you to reuse the code across multiple scripts. Here's an example of a function called new-AZ Virtual Network. This function establishes reusable logic by defining parameters and detailing the steps to create a virtual network. To use the new-AZ Virtual Network function, call it with specific values like the resource group, location, name, and address prefix. Executing this call provisions the virtual network. By modularizing your code this way, you keep your scripts clean and organized, enhancing both their readability and reusability. In scenarios where you need to provision similar resources with slight variations, parameterized scripts provide a way to input different values for resource properties, such as names or configurations, without altering the core script. Let's explore an example of how to parameterize a script to provision virtual machines. First, create a script that includes a param block, which defines the parameters that can be passed into the script. You can also set default values for optional parameters, such as $VM size equals standard DS1 v2. This script also includes the new -azvm commandlet, which provisions the virtual machine according to the values passed to the parameters. Next, save this script with a file name, such as provisionvm.ps1, so that it can be reused. To run the script, call it using its file name, provisionvm.ps1, and provide specific values for each parameter. This approach passes the required values into the script, allowing it to provision a virtual machine with the specified configuration without changing the script itself. Parameterizing scripts in this way enhances their flexibility and reusability, making your automation processes more efficient. Another key technique you can use in PowerShell is error handling with try, catch, and finally blocks, which helps your scripts handle failures gracefully and maintain control during unexpected situations. In this script, the try block contains the main logic for provisioning the storage account. The catch block manages any errors that occur during the process, allowing you to display an error message or take corrective action. And the finally block runs code that executes regardless of whether the try block succeeds or fails, such as logging or performing cleanup tasks. Implementing error handling ensures that your scripts can continue operating, managing errors effectively, and clean up resources when things go wrong. Finally, integrating Azure PowerShell with continuous integration, continuous deployment, or CI/CD pipelines is a powerful technique that automates the deployment and provisioning of resources as part of your development lifecycle. PowerShell scripts in CI/CD pipelines can provision infrastructure, configure environments, and deploy applications automatically. Let's discuss a few key benefits of integrating PowerShell with CI/CD pipelines. Firstly, PowerShell scripts enable infrastructure as code, or IAC. This allows you to define and manage your infrastructure through code, ensuring deployments are automated and consistent. Next, integrating PowerShell scripts into your CI/CD pipeline automates resource provisioning. This means that with each new build or release, your infrastructure remains consistent across environments. Lastly, using PowerShell scripting in CI/CD pipelines scales your operations by automating repetitive tasks, reducing manual errors, and accelerating deployment processes. Throughout this video, you've learned how advanced PowerShell scripting transforms your Azure resource management. By using modular scripting, error handling, and CI/CD pipelines, you can automate complex tasks, maintain consistency, and achieve your company's goals. These advanced techniques empower you to build more efficient, reliable, and scalable cloud environments. As an IT professional, managing hundreds of users and applications across multiple Azure subscriptions manually can take hours. Each new user or application increases the chances for errors, leading to potential security vulnerabilities. Sound daunting? With Microsoft PowerShell and Entra ID, it doesn't have to be. PowerShell goes beyond basic scripting. Paired with Entra ID, it's a powerful tool for automating complex identity and access management across your cloud infrastructure. In this video, you'll explore advanced strategies for using PowerShell with Entra ID to enhance security practices, automate identity management, and integrate these capabilities into broader cloud operations. Remember, the descriptions of the commandlets are simplified to only include commandlet names, but the precise syntax will be displayed on screen. Let's begin with exploring how integrating Entra ID with PowerShell can help you streamline identity management tasks. You're likely already familiar with Entra ID and its critical role in managing identities within Azure. However, its true potential emerges when you use PowerShell to automate and scale identity management processes. Combining Entra ID with PowerShell allows you to manage large numbers of identities, enforce strict access controls, and automate repetitive tasks, all from the command line. Managing complex environments often requires handling multiple tenants and subscriptions. PowerShell simplifies these tasks, ensuring consistency and reducing human error. For example, to switch between Azure subscriptions, use the select-az context commandlet with the subscription ID parameter to select a specific subscription. And to retrieve a list of your Azure subscriptions, use the get-az subscription commandlet to display properties like subscription name and subscription ID. By automating these transitions and commandlets, you ensure your scripts are adaptable and capable of managing different environments. When scalability is crucial, like managing hundreds of applications or automating continuous integration, continuous deployment, or CI/CD pipelines, service principals become indispensable. A service principal serves as a secure, non-interactive identity that allows applications and automated tools to perform actions in Azure. Instead of manually managing service principals, PowerShell can automate their entire lifecycle, from creation to role assignment and decommissioning. You can achieve this by writing scripts that not only create service principals, but also securely retrieve and store their credentials using Azure Key Vault. This integration also ensures that your automation processes are both scalable and secure. Here's a script snippet that creates a service principal and securely stores its credentials in Azure Key Vault, enabling safe, scalable automation. In Entra ID, dynamic groups automatically include members based on specific criteria like user attributes, making group management more efficient and automated. For example, you can create a dynamic group that automatically adds users from a specific department based on the department attribute in their user profiles. To automate dynamic group management in Entra ID with PowerShell, you'll use the Microsoft Graph Application Program Interface, or API. This is because dynamic groups can't be directly managed using the Entra ID module. So let's explore how you can automate dynamic group creation and management with PowerShell and the Microsoft Graph API. First, ensure you have the necessary modules and authentication set up. Run the install module commandlet to install the Microsoft Graph PowerShell module if you haven't. Next, use the connect-mggraph commandlet to authenticate to Microsoft Graph. This ensures a secure connection, allowing you to execute commandlets and manage resources within your Azure environment through the Microsoft Graph API. Once authenticated, you can create a dynamic group where users are automatically added based on a specific attribute, such as their department. For example, if you want to automatically include all users from the sales department, here's how to set that up. This script first defines the properties for the new dynamic group, including the display name, description, membership rule, and rule processing state. Then it creates the dynamic group using the new-mggroup commandlet. The membership rule ensures that any user whose department is set to sales will be automatically added to the group. Once the group is created, the script outputs a confirmation message indicating that the dynamic group was successfully created. Once the group is set up, you may want to verify its details. This script retrieves the dynamic group using its ID and displays key details such as the group's name and membership rule. This allows you to confirm that the group was created correctly and that the membership rule is applied as expected. Finally, if you need to update the membership rule, for example, to switch from including sales to marketing, this script uses the update-mggroup commandlet to update the dynamic group's membership rule, automatically including users from the marketing department. It then displays a confirmation that the update was successful. In this video, you've learned how to streamline identity management and scale automation with PowerShell and Entra ID. This powerful combination not only automates identity and access management, but also ensures security across your Azure environments, reducing manual errors and saving time. Leveraging advanced PowerShell scripting for Entra ID management empowers you to automate and scale identity and access management tasks, ensuring your Azure environment remains secure and efficient.
Have you ever wondered what it's like to receive an alert about a potential security breach in a large corporation? What challenges would you face in quickly identifying and mitigating the threat to protect your organization's data and systems? In this video, you will explore Microsoft Sentinel's core features, including data ingestion, threat detection, investigation, and automated response capabilities. You will learn how you can leverage these tools to manage, monitor, and respond to security threats and ensure the safety of your IT infrastructure. First, let's discuss what a Security Information and Event Management, or SIEM, system is. A SIEM system is a tool that helps organizations keep their computer systems safe. It works by collecting and analyzing data from various parts of the system, such as hardware like computers and servers, and applications like software programs. This system helps manage logs or records of events, sends alerts when something unusual happens, provides visual displays of data, assists in handling security incidents, and allows users to search through data to find specific information. In simple terms, a SIEM system acts like a security guard for all the digital components of a business. For example, it can enable you to detect unusual login attempts from different geographic locations, identify patterns indicative of potential data breaches, and automatically trigger alerts to notify the security team for further investigation and action. Now, what is Microsoft Sentinel? It is a cloud-native SIEM system designed to help security operations teams gain security insights across the enterprise by collecting data from virtually any source. It enables quick detection and investigation of threats using built-in machine learning and Microsoft Threat Intelligence. Think about how this could streamline your threat detection process. Microsoft Sentinel also automates threat responses through playbooks and Azure Logic Apps integration. Unlike traditional SIEM solutions, Microsoft Sentinel does not require the installation of servers either on-premises or in the cloud. As a service deployed in Azure, it allows you to get up and running within minutes through the Azure portal. Sentinel is tightly integrated with other cloud services, enabling seamless log ingestion and native use of other cloud services for tasks like authorization and automation. As an end-to-end security operations tool, Sentinel includes functionalities for data collection, threat detection, investigation, and response. Now let's explore how Microsoft Sentinel works. Imagine consolidating all your security data from multiple sources into one place, simplifying and enhancing your security operations. The first step is ingesting data through data connectors. These connectors allow you to add various services, such as Azure Activity Logs, with a simple selection, while other services like syslog may require some configuration. Data connectors cover a wide range of scenarios and sources, including syslog, Common Event Format or CEF, Trusted Automated Exchange of Indicator Information or TAXI, Azure, and AWS services. After ingestion, data is stored using Log Analytics, which offers the powerful Kusto Query Language or KQL for querying your data. KQL is a powerful query language that allows you to deeply explore and gain insights from your data. Next, you can visualize your data using workbooks in Microsoft Sentinel. Think of workbooks as customizable dashboards, each built using an underlying KQL query. You can quickly create and customize these dashboards to monitor critical security metrics using built-in workbooks or creating new ones from scratch. Next, to proactively monitor your data, Microsoft Sentinel allows you to enable built-in analytics alerts within your workspace. These alerts can be customized, and some are based on proprietary machine learning models from Microsoft. You can also create custom scheduled alerts to suit your specific needs. Furthermore, Microsoft Sentinel offers built-in hunting queries for Security Operations Center or SOC analysts. Analysts can create custom queries to proactively search for threats and investigate suspicious activities within their network. They can also leverage Azure Notebooks for advanced threat hunting using programming languages. Incidents are generated when enabled alerts are triggered. Microsoft Sentinel supports standard incident management tasks such as changing statuses or assigning incidents. Additionally, it offers investigation functionality, allowing you to visually investigate incidents by mapping entities across log data along a timeline. Finally, automation playbooks in Microsoft Sentinel enable automated responses to incidents, making your SOC more productive. These playbooks can manage incident workflows, enrichment, investigation, and remediation tasks as part of Sentinel's Security Orchestration Automation and Response, or SOAR capabilities. So when should you use Microsoft Sentinel? Microsoft Sentinel is a versatile solution for performing security operations across both cloud and on-premises environments. You can collect event data from various sources and analyze it for suspicious activity. Key security operations you can use Sentinel for include visualizing log data, detecting anomalies, threat hunting, investigating security incidents, and automating responses to alerts and incidents. In conclusion, Microsoft Sentinel provides an end-to-end solution for security monitoring, from data ingestion and analysis to incident management and automated response. It's an ideal choice if you want to enhance your organization's security posture with a scalable cloud-native SIEM solution integrated with Microsoft's extensive suite of security tools and services. When you're working in an IT environment, monitoring vast amounts of data to identify potential security threats can feel like a challenging task. So what can you do to efficiently manage this crucial responsibility? In this video, you will delve into the key concepts of log collection and the application of detection rules within Microsoft Sentinel. By mastering these critical components, you will be better equipped to strengthen your organization's security posture and respond effectively to potential threats. Let's start with log collection. Log collection involves gathering log data from various sources such as applications, devices, and infrastructure components and putting it into a central repository. This data is crucial for monitoring, analyzing, and responding to security incidents. Effective log collection is essential for several reasons. It enables continuous security monitoring to identify unusual or suspicious activities, ensures compliance with regulatory requirements, and provides a historical record for forensic analysis. By centralizing logs, you can correlate events from different sources, providing a more comprehensive view of your security landscape. This means you have the ability to review all your security data in one place and respond instantly to threats. Once you onboard Microsoft Sentinel into your workspace, you can use data connectors to ingest your data. Microsoft Sentinel includes many out-of-the-box connectors for Microsoft services that integrate in real time. Data connectors cover a wide range of scenarios and sources, including syslog, Common Event Format or CEF, Trusted Automated Exchange of Indicator Information or TAXII, Azure, and AWS services. After logs are ingested, they are stored using Azure Log Analytics. This storage allows for extensive querying and analysis using the Kusto Query Language or KQL. KQL supports complex queries, joins, and aggregations, making it possible to extract meaningful information from vast amounts of log data. Using KQL, you can write detailed queries to analyze your log data and generate valuable insights. Now let's explore what detection rules are and the various types of detection rules you have access to. Detection rules in Microsoft Sentinel are predefined or custom rules that analyze ingested log data to identify suspicious activities or potential threats. These rules generate alerts when specific conditions are met, allowing your security teams to respond promptly to threats. Within Microsoft Sentinel, you have access to different types of detection rules, including analytics rules, machine learning-based rules, and fusion rules. Let's explore the available analytics rules and rule templates. Firstly, scheduled rules are the most common type of analytics rule. They run at regular specified intervals, analyzing log data based on predefined queries to ensure continuous monitoring. Secondly, near real-time or NRT rules are designed to provide up-to-the-minute information. These rules are hard-coded to run every minute, capturing events as they happen. Thirdly, anomaly rules use machine learning to detect unusual behaviors based on established baselines, identifying potential threats that deviate from the norm. Fourth, Microsoft security rules integrate with other Microsoft security solutions to create incidents in Sentinel from alerts generated by these tools. Lastly, specialized templates includes rules for threat intelligence, fusion, and machine learning behavior analytics, providing advanced capabilities for specific security scenarios. These analytics rules and templates allow you to tailor your security monitoring to your organization's specific needs, ensuring that you can quickly detect and respond to a wide range of security threats. Next, Microsoft Sentinel also provides access to machine learning-based rules. These rules use machine learning-based models to detect anomalies and sophisticated threats that traditional rules might miss. These models can also learn from historical data to identify patterns that signify potential threats. What's more, Sentinel provides access to fusion rules. These rules combine multiple data sources and analytics techniques to identify complex attack patterns such as multi-stage attacks or coordinated campaigns. Finally, let's explore a few important aspects to consider when creating and managing detection rules. To create and manage detection rules, you need to define the conditions and logic to analyze log data, specify the rule logic using KQL, set alert thresholds, enable the rule, and then monitor its performance. Cyber threats constantly evolve, requiring your detection rules to adapt to new attacker tactics and techniques. Therefore, it's crucial that you ensure your detection rules are regularly updated to address new threats and vulnerabilities. You can also integrate threat intelligence feeds to enhance detection rule accuracy. This involves incorporating up-to-date information on known threats such as malicious IP addresses, domains, and file hashes into detection rules for improved effectiveness. Log collection and detection rules are vital components of Microsoft Sentinel's security operations capabilities. By effectively collecting log data from various sources and applying robust detection rules, you can enhance your security posture, quickly identify potential threats, and respond effectively. By now, you should have a good understanding of what Microsoft Sentinel is and how it can be used to collect and analyze logs. Now, suppose you're a security analyst tasked with setting up and managing incidents and alerts. Being able to effectively set up and manage security incidents and alerts in Microsoft Sentinel ensures you can swiftly address potential threats. In this video, you will explore how to configure and manage security incidents and alerts in Microsoft Sentinel. Let's start by exploring how to create analytics rules. Analytics rules in Microsoft Sentinel are vital for detecting threats and triggering alerts. These rules use Kusto Query Language, or KQL, to analyze data and spot suspicious activities. By creating a new rule, you can set the parameters and conditions for detecting potential threats. This proactive approach helps you identify and address issues early, ensuring your environment remains secure. To create a rule in the Sentinel workspace, navigate to the Configuration section and select Analytics. The Analytics page provides a centralized location where you can view, create, and manage your analytics rules. This provides streamlined management and easy access to configurations. In the toolbar, select Create and then Scheduled Query Rule. This will open a wizard to help you set up your new rule. The wizard guides you step by step to ensure all necessary parameters are correctly defined. This also minimizes the risk of misconfigurations that could lead to missed threats or false positives. On the General tab, under the Analytics Rules section, Enter the name, description, and severity of the rule. Ensure the name is descriptive enough to understand its purpose at a glance. The severity can be set to informational, low, medium, or high, depending on the potential impact of the threat on your organization. Selecting the appropriate severity helps prioritize the incident response efforts effectively. Next, on the Set Rule Logic tab, define the query logic using KQL. This query will specify the conditions that need to be met for the rule to trigger an alert. For example, you might create a rule to detect multiple failed login attempts within a short period. Next, scroll down and under the Alert Threshold section, set the thresholds for triggering alerts. Thresholds are the specific conditions or limits that must be met for an alert to be generated. For example, in the wizard, you might set the threshold by selecting is greater than and entering 5 to trigger an alert when the number of failed login attempts exceeds 5. You can also configure automated responses, such as running a playbook when an alert is triggered. This ensures immediate action is taken to mitigate the threat, reducing potential damage to your organization. Once you've configured everything, save the rule and make sure it is enabled. Your rule will now start monitoring the specified conditions. Saving and enabling the rule activates your monitoring setup, ensuring that the defined threats are detected and alerts are generated in real time. Now let's explore how to manage incidents that are generated from these alerts. Incidents help you organize and manage your response to security threats. In the Sentinel workspace, select Incidents from the left-hand menu. This displays a list of all current incidents. Next, select an incident to access its details. Here you can find information about the related alerts, entities involved, and the timeline of events. Use the investigation tools to explore the incident in detail. This might involve examining related alerts, analyzing the affected entities, and reviewing the timeline to understand the sequence of events. Investigating incidents thoroughly helps you understand the root cause and impact, allowing for more effective resolution and prevention of future incidents. Based on your investigation, you can take various actions such as assigning the incident to a team member, changing its status, or running a playbook to automate the response. Effective incident response requires clear communication and coordination among team members. Assigning the incident ensures accountability, while automated responses through playbooks can help in quickly mitigating the threat, thereby reducing the potential impact on your organization. Once resolved, you can close the incident or escalate it if further action is needed. Keeping your incident statuses up to date is crucial for maintaining an effective security posture. Closing or escalating incidents appropriately ensures that all threats are adequately addressed, preventing any oversight that could lead to vulnerabilities. Configuring analytics rules and managing incidents greatly enhances your organization's security monitoring and response. Success with Microsoft Sentinel depends on continuously monitoring and refining your rules and responses as threats evolve. Regularly updating and optimizing your configurations ensures proactive threat detection and mitigation, maintaining a strong security posture. You previously learned about log collection, detection rules, and configuring incidents and alerts in Microsoft Sentinel. Now, suppose you're a security analyst tasked with investigating and managing security incidents. Being able to handle these incidents effectively in Microsoft Sentinel ensures you can swiftly address potential threats and protect your organization's assets. In this video, you will explore the workflow of incident investigation and response using the powerful tools available in Microsoft Sentinel. To start, let's discuss a few essential aspects of investigating incidents. Investigating incidents is a critical part of the security operations workflow. It involves understanding the scope of the incident, identifying the affected entities, and determining the cause and impact. This process helps you formulate an effective response strategy and mitigate future risks. Let's explore how to action this process in Azure Sentinel. Firstly, in the Sentinel workspace, select Incidents from the left-hand menu. This displays a list of all incidents that have been generated. You can use the centralized view to prioritize and manage your response effectively. Next, select an incident to view its details. The incident page provides a comprehensive overview, including the severity, status, and related alerts. Having this detailed information readily available aids in making informed decisions quickly. For example, if an incident has a high severity, you can prioritize it for immediate action. Then, on the Incidents page, select the Timeline tab. The Timeline view displays the duration and sequence of events related to the incident. This helps you understand the scope of the incident, how it evolved over time, and identify key actions that led to it. To investigate the scope of the incident further, select the Alerts tab. This view displays the alerts that are associated with the incident. Each alert provides detailed information about the suspicious activity that triggered it. For example, an alert might show repeated access attempts to sensitive files, indicating potential data exfiltration. By analyzing these alerts, you can determine the root cause of the incident and assess its impact. The next step is to identify the affected entities. Entities are the objects involved in the incident, such as users, IP addresses, or devices. Identifying these entities helps you understand who or what was impacted by the incident and how they are related. For example, identifying the user account and device used in a suspicious login can help you trace the source of the threat and understand its impact on your network. Once you have a clear understanding of the incident, it's time to respond. Effective response involves coordinating actions to mitigate the threat and prevent future occurrences. As part of responding to an incident, some of the actions you can take are: assign the incident, change the incident status, run a playbook, document findings and actions, and close the incident. You can assign the incident to a specific analyst or team member. This ensures accountability and helps track who is responsible for the response. It's important to update the status of the incident as you progress through the investigation and response. For example, you might change the status from new to in progress or resolved. Regularly updating the status provides a real-time view of incident handling, ensures transparency, and keeps all stakeholders informed about the current state of the incident. Sentinel also allows you to automate responses using playbooks. Playbooks are collections of automated actions that can be triggered in response to an incident. For instance, you can run a playbook to isolate a compromised device or notify stakeholders. Automating responses with playbooks ensures quick and consistent actions, reducing the impact of incidents. The next important step in the process is to document your findings and the actions taken during the incident investigation. Use the Notes section to add detailed information about the incident and your response. Thorough documentation is crucial for future reference, supporting incident reviews, and fostering continuous learning and improvement. Once the incident has been fully investigated and the necessary response actions have been taken, you can close the incident. This helps keep your incident queue organized and focused on current threats. Properly closing incidents ensures your team remains focused on active threats and maintains a clear overview of ongoing security activities. Now that you understand the steps in responding to incidents, let's go over a few best practices to help you manage incidents effectively in Microsoft Sentinel. Firstly, regularly review and update your analytics rules. This ensures that your detection capabilities stay current with the evolving threat landscape. Secondly, conduct post-incident reviews. After closing an incident, analyze the response process to identify any gaps or areas for improvement. Thirdly, leverage threat intelligence. Integrate threat intelligence feeds to enhance your incident investigation and response capabilities. Finally, foster collaboration and information sharing within your team. Sharing insights and learnings from each incident helps in building a resilient security posture. Effectively managing security incidents is essential for maintaining a secure and resilient IT environment. By thoroughly investigating incidents, identifying affected entities, and determining the root cause and impact, you can develop an effective response strategy. Regularly reviewing and updating your analytics rules, conducting post-incident reviews, leveraging threat intelligence, and fostering team collaboration are all critical practices that enhance your incident management capabilities. Proper incident management not only mitigates potential threats, but also strengthens your overall security posture, preparing your organization to handle future challenges with confidence. As businesses increasingly adopt cloud-based solutions, the ability to efficiently and securely manage Azure resources is a more relevant skill than ever. That's why in this module, you explored 3 tools that assist with this purpose: Azure Command Line Interface or CLI, Azure PowerShell, and Microsoft Sentinel. Now, let's recap the key insights you have gained about these tools. You started by learning how to set up and use Azure CLI for managing resources through powerful command line operations. You became familiar with the role of commands in provisioning, managing, and automating Azure environments. Security was the next central theme, where you discovered various authentication methods, including interactive browser-based authentication, device code flow, service principal, and managed identities. These practices ensure that only authorized users and processes can interact with your Azure environment, enhancing overall security. You later explored essential Azure CLI commands, their structure, and how to use them to efficiently manage and optimize Azure resources. You also discovered how integrating bash commands with Azure CLI enables you to automate resource deployment, streamline tasks, and dramatically boost productivity. Furthermore, advanced techniques for querying and filtering command outputs were covered, teaching you to extract only the information you need from complex results. Following that, you were introduced to the interactive mode of Azure CLI, which provides a guided environment for executing commands and improves your overall command line experience. You later picked up practical tips for optimizing your use of Azure CLI, focusing on environment setup, resource management strategies, and performance enhancements. You then moved into using more advanced Azure CLI techniques, including using James path queries and various output formats to extract, manipulate, and present your data. Next, you discovered how to integrate Azure CLI with Entra ID services. You learned how to use this combination to manage identities, control access, and implement security measures across your Azure environment. To wrap up this section, you explored practical applications of Azure CLI in real-world scenarios such as infrastructure as code or IAC, CI/CD pipelines, and DevOps workflows. You found out how to automate resource deployments, manage access controls, and streamline processes like disaster recovery and scaling, all of which are crucial for maintaining efficient and resilient cloud environments. In the second part of the module, your focus shifted to Azure PowerShell. Here, you started by learning the basics of Azure PowerShell, its benefits, and how to install it on different operating systems, including Windows, Mac OS, and Linux. You then unpacked various identity and authentication methods that provide a robust framework for controlling access and maintaining secure operations. Additionally, you learned about the basic structure of PowerShell commandlets and which ones to use for retrieving system information, managing files and folders, handling users, and accessing help within the system. Next, you explore the integral role of application programming interfaces or APIs in automation, understanding how PowerShell can interact with these interfaces to retrieve data, perform tasks, and manage resources programmatically. Another key skill you picked up was manipulating and extracting relevant data using specialized commandlets like select object, where object, and sort object, which enable you to work with clean, organized data. Working in interactive mode within PowerShell was the next discovery that further enhanced your scripting capabilities. This feature allows you to execute commandlets step by step, view immediate results, and fine-tune your scripting approach on the fly. Next came practical tips and best practices for PowerShell, including environment setup, error handling, and optimization strategies. These insights help you improve workflows and the overall efficiency of your operations. You also explored advanced scripting techniques in PowerShell, such as using functions, parameterized scripts, error handling, and CI/CD pipelines. These techniques help streamline Azure resource provisioning. From here, you moved on to advanced strategies for using PowerShell with Entra ID. This powerful combination allows you to simplify identity management and scale automation within your Azure environment. Finally, this section delved into specialized scripting techniques for specific Azure resources, emphasizing modularity, error handling, and security best practices. This section also covered the implementation of desired state configuration or DSC. DSC ensures your resources remain in a predefined, compliant state, further automating the management of Azure infrastructures. In the final part of the module, you were introduced to Microsoft Sentinel, a cloud-native security information and event management or SIEM solution. You discovered how Sentinel provides comprehensive security monitoring, data ingestion from various sources, threat detection, and automated response capabilities. You also learned how it leverages machine learning and built-in threat intelligence to help you identify and respond to threats quickly. Additionally, you learned about Sentinel's seamless integration with other Azure services and its scalability to meet your organization's security needs. You then covered log collection and detection rules in Microsoft Sentinel, focusing on gathering data from various sources and using Kusto Query Language or KQL for analysis. You learned how effective log collection is crucial for continuous security monitoring and threat detection. For instance, collecting logs from firewalls, virtual machines, and applications provides a holistic view of your security posture, enabling proactive threat detection. Next, you explored configuring security incidents and alerts in Sentinel. You learned to create analytics rules with KQL to detect threats and trigger alerts and set alert thresholds for proactive threat detection. Additionally, you covered configuring automated responses with playbooks and managing incidents by examining alerts, assigning incidents, and documenting findings. Finally, you were guided through the workflow for investigating and managing security incidents in Sentinel. You learned about thorough investigation, root cause analysis, and effective response strategies, and how these ensure that you can swiftly address potential threats and protect your organization's assets. You discovered how Sentinel's investigation tools allow you to map the timeline of events, identify affected entities, and determine the root cause of incidents. Additionally, throughout this module, you engaged in various activities and readings that reinforced the knowledge you gained. As you prepare for the module quiz, remember that you can return to any of the videos, readings, or activities if you feel like you need to reinforce your understanding of key concepts or tools. Good luck with the quiz. You've got this. Congratulations on nearing the completion of this course. You've put in a lot of hard work and you should be proud of your efforts. Getting here means that you've greatly increased your knowledge of cloud computing in the areas of Azure Compute, with the focus on virtual machines, app service, and Azure Kubernetes Service or AKS, Azure networking, including virtual networks, load balancing, and identity and access management, and security in Azure, particularly where resource management is concerned. Before jumping into the course project and final assessment, let's take a moment to review everything you've learned. You began the course by discussing the key concepts of Azure Virtual Machines or VMs. You explored several deployment options, including the Azure Portal, Azure Resource Manager or ARM templates, and Azure CLI. Each method offers unique benefits from ease of use to automation capabilities. You also practiced deploying VMs using different methods and studied advanced configuration options such as custom scripts, managed disks, and virtual network integrations, which allow you to tailor VMs to specific needs. Next, you explored the best practices for optimizing VM performance and security. Remember, using Azure Monitor, keeping VMs updated, and employing Azure Security Center are essential steps in maintaining a secure and efficient environment. You then covered Azure App Service, exploring features and benefits such as easy deployment, built-in scaling options, and integrated DevOps capabilities. You studied various deployment and scaling strategies for web applications, which make it easy to manage web apps. You also practiced deploying web apps with Azure App Service, applying different scaling strategies that ensure your applications can handle varying loads. Moving on to container orchestration, you explored the role of AKS and studied the steps involved in deploying and managing AKS clusters, including setting up nodes and deploying containerized applications. You also covered cluster management, security, and best practices for deploying containerized applications. Your practical experience managing containers with AKS highlighted the importance of network policies, RBAC, and regular updates. In the second module, you discovered that Azure Virtual Networks form the backbone of your network infrastructure, and you also explored several subnetting techniques network security configurations, and advanced options like network security groups or NSGs. You then picked up best practices for securing network traffic within Azure Virtual Networks. These included configuring NSGs, using Azure Firewall, and regularly reviewing security rules to ensure optimal traffic management and security. Following this, you discovered that Azure Load Balancer is crucial for distributing traffic and controlling network routes. You explored load balancing algorithms, configuring rules, and best practices that ensure high availability and reliable application delivery. Identity and Access Management, or IAM, was another critical area you covered. You learned how to manage users, groups, and roles through RBAC, as well as how to define custom roles to maintain security and compliance. You then examined best practices for securing access to Azure resources through IAM to ensure that only authorized users have access to critical resources. In Module 3, the primary topic was securely configuring resources within an Azure environment. You explored 3 tools for doing this, which are Azure CLI, Azure PowerShell, and Microsoft Sentinel. Let's recap the features and benefits of each one. Azure CLI is a cross-platform tool for managing and interacting with Azure resources using simple commands. Resource types that you can configure with it include resource groups, virtual machines, storage accounts, and virtual networks. Azure CLI enables automation of many tasks associated with these types, and task scripts can be easily shared and reproduced to increase efficiency. Azure PowerShell is a scripting language and command line shell for managing and automating tasks in Windows environments. Its capabilities and benefits are similar to those of Azure CLI, so choosing a tool often comes down to determining the language that is most readily usable for the organization. And then there is Microsoft Sentinel, which is a security information and event management or SIEM solution that plays a large role in security monitoring for Azure environments. You explored Sentinel's capabilities for log collection and detection rules, and you learned best practices for configuring security incidents and alerts. You also discovered that the workflow of incident investigation and response in Sentinel is crucial for maintaining a secure environment. Now that you've recapped the key topics from this course, you will undertake a project to implement a secure, scalable Azure environment that incorporates a virtual infrastructure. Throughout this course, you have gained the knowledge needed to complete this project, but feel free to revisit the course materials if you need a refresher on any topic. Good luck! Congratulations on reaching the end of Secure and Scalable Cloud Infrastructure with Microsoft Azure. By completing this course, you have developed a solid understanding of what Microsoft Azure solutions are available, including Azure Compute, Virtual Machines, App Services, and Azure Kubernetes Service, or AKS. You've also explored Azure Networking, which expanded your knowledge of virtual networks, load balancing, and identity and access management. You later became familiar with several key Azure tools for resource security and management, specifically Azure CLI, Azure PowerShell, and Microsoft Sentinel. Through a mix of videos, readings, and activities, you've gained a solid foundation in the benefits and use cases of several Azure services, the deployment and management of virtual machines, various scaling strategies, and key networking features that enhance the management and security of Azure. Additionally, you completed the final course project where you deployed a secure and scalable Azure environment. Well done on taking the next step toward your future career. Remember, by successfully completing all the courses in this program, you will earn a Coursera certification. In addition to proving your cloud computing knowledge, this globally recognized certification significantly boosts your credibility and appeal to prospective employers. Completing the program also serves as an essential stepping stone in your preparation for the Microsoft Certified Exam AZ-900 Microsoft Azure Fundamentals. Passing this exam earns you a certification that provides industry-endorsed evidence of your skills, further enhancing your employability and career prospects. This AZ-900 Microsoft Azure Fundamentals exam demonstrates your knowledge of Azure components and services such as compute, network, and storage. It will also test your understanding of key skills including cloud concepts, Azure architecture and services, and Azure management and governance. In summary, this course has enhanced your knowledge and skills in key aspects of cloud computing. However, you might wonder what lies ahead. There's still more to discover, making it beneficial to enroll in the next course. Whatever you do next, You have already demonstrated your ambition, competence, and readiness to tackle new challenges for any new employers, and you should be proud of your progress. Wishing you continued success as you continue down your educational path.